All the students sitting in the front row, please maintain silence. Everyone are requested to please put your mobile phones inside. I request everyone, please put your mobile phones inside. If there is any query, our volunteers are there to help you. Please ask them and maintain a good rapport with them. I request every student to maintain a good rapport with the volunteers present beside you. A radiant morning to all. With immense honor, I extend a warm and grand welcome to our honorable chief guest, guest of honor, and president of the function, respected dignitaries, respected professor, distinguished guest speakers, esteemed dignitaries from Devi's laboratories, brilliant researchers, and enthusiastic students, both from our university and beyond. Your gracious presence today elevates this occasion, and we are truly privileged to have such a gathering to intellectual excellence and innovation. As a token of our heartfelt gratitude, we appreciate your deepest appreciation and participation in this workshop. With that spirit, we, the engineers of tomorrow, stand before you today, not just as anchors, but as voices advocating for sustainable industrial practices. Myself, Zainul, and with me is my dynamic host, Tanmay, and together we welcome you all to this international conference on sustainable practices for industrial pollution control. We are honored to stand before you today as students of Andhra University, an institution that has been a beacon of knowledge and excellence since its inception in 1926. Over the decades, Andhra University has stepped up vastly its commitment to academic brilliance and research and innovation. Andhra University, a symbol of heritage and academic legacy, was established in the year 1926 by Sir C.R. Reddy Garu, its first Vice Chancellor. Since then, it has been a hub of innovation, research, and excellence. With 121 academic and administrative buildings, the university offers 63 courses in science and technology, diverse engineering programs, and pharmaceutical sciences. Andhra University College of Engineering holds a prestigious place in South India, standing as a pioneer in technical education and innovation. The university's dedication to quality education is exemplified by its recent achievement of an A++ grade with a CGPA of 3.74 from the National Assessment and Accreditation Council (NAC), reflecting its unwavering pursuit of excellence. A pioneer in engineering education, the university established its College of Engineering in the year 1946. Notably, the foundations of technical education were laid in the year 1933 with the introduction of sugar technology, a pioneering initiative that later evolved into the prestigious Department of Chemical Engineering, shaping generations of engineers and researchers. Established as the second oldest chemical engineering department in India, it has a proud history spanning decades, celebrating its platinum jubilee in the year 2008. It is the only department in the College of Engineering to have reached this prestigious milestone. It was founded by Professor C. Venkatrao Garu back then, and the department offers a wide range of programs including 2 UG, 5 PG, and a BTech plus MTech dual program and PhD programs with NBA accreditation and AICTE approval. It continues to uphold the highest academic and research standards. Recognized by the Institution of Chemical Engineers, United Kingdom, are the 20 chemical engineering departments in India and the only one in Andhra Pradesh and Telangana. As a center of technical excellence under TCAP 2 Phase 2, the department has received rupees 5 crores in funding to support advanced research and infrastructure. With 91% of faculty holding PhD degrees, we take pride in our commitment to high quality education and cutting edge research. Its alumni have played a pivotal role in shaping academia, industry, and governance. Many have held leadership positions in IITs, NITs, and global institutions. Distinguished alumni include Professor G.J.V. Jagannatharaju Garu, former Vice Chancellor of Nagarjuna University, Professor G.P. Rangaya Garu from National University of Singapore, along with top executives in Meta, HPCL, and Bank of America. The department students have consistently exceeded securing top ranks in GATE and other competitive exams, national awards, and gaining internships in leading industries and research centers. With a placement record of 75% and over 250 offers in 2022 alone, our graduates are making an impact worldwide. Our commitment to research and innovation is reflected in 7 research laboratories, multiple patents, 182 publications, and R&D projects worth rupees 2.88 crores. The department also hosted numerous workshops, conferences, and career guidance programs to foster holistic learning. Most importantly, we are conducting today's event in the very auditorium that stands as a symbol of our department's enduring legacy, the Dr. Y.V.S. Murthy Auditorium. Dr. Y.V.S. Murthy Garu, a visionary industrialist, scientist, and a profound alumnus, contributed rupees 2.5 crores for the construction of this state-of-the-art facility. His generosity and unwavering support for education continue to inspire generations of students and faculty. We take immense pride in being part of this legacy of knowledge and innovation leadership. Here's to the continued success and impact of Department of Chemical Engineering. As we transition into our workshop, sustainability is not just a goal, it is a responsibility. The discussions, research, and knowledge shared today serve as the catalyst for a cleaner, greener, and more responsible industrial future. Like a perfectly balanced equation, sustainability requires precision, effort, and commitment from every one of us. Let this conference be a stepping stone towards industries that no longer compromise with nature, but rather coexist in harmony with it. From waste minimization and resource recovery to cutting-edge absorption and biodegradation techniques, chemical engineering offers solutions that transform pollutants into possibilities. Today, as we explore pioneering strategies and breakthrough technologies, we take a step toward a bright future where industry don't just grow but sustain. This workshop serves as a platform for insightful discourse, pioneering research, and collaborative innovation. We aspire that the expertise shared today translates into tangible advancements in pollution control and sustainable development. And now, let's witness an enchanting blend of grace and rhythm, semi-classical dance fusion by Shruti, Kausalya, and Deepika that actually promises to leave us mesmerized.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रान्विता या वीणा वरदण्डमण्डितकरा या श्वेता पद्मासना या ब्रह्माच्युत शङ्कर प्रभृतिः
Now we invite the president of today's inaugural function, Professor D. Appalnaidu Garu, who is also the in-charge head of Department of Chemical Engineering, to address the dignitaries, participants, and professors with a welcome speech.
Good morning. Good morning, all of you. The dignitaries on the dais and off the dais, chief guest of today's function, Dr. Tata Prakashan Garu, Executive Director, Center for Transformation of Waste Technology, Naperville, USA. The guest of honor, P. Srinivas Rao, Environmental Engineer, AP Pollution Control Board. Convener of the workshop, Professor V. Sridevi. Co-convener of workshop, Professor V. Meena. Guests from industry, sponsors, and participants of this workshop, faculty from other departments, faculty and staff of our department, research scholars, students, and press and media. It gives me immense pleasure to welcome you all to this workshop organized by the Department of Chemical Engineering, Andhra University College of Engineering, in collaboration with Indian Institute of Chemical Engineers, Walther Regional Center. This event brings together experts, researchers, and industry professionals to discuss practical solutions for minimizing industrial pollution and ensuring sustainable growth. Our Department of Chemical Engineering, Andhra University, is the second oldest department in our country, started in the year 1933, which has distinguished legacy of academic excellence, research innovation, and strong industry collaborations. Our department is committed in shaping future engineers through cutting-edge research, practical training, and industry-relevant curriculum. We focus on process engineering, energy conservation, advanced separation techniques with environmental sustainability, ensuring that our students are equipped to address global challenges. We take pride in fostering industry academia partnerships and organizing workshops like this to encourage knowledge exchange and innovation in green and sustainable technologies. The theme of this workshop, Sustainable Practices for Industrial Pollution Control, is of immense relevance today. As industry expands, their environmental footprint grows, making it crucial to adopt eco-friendly, efficient, and regulatory compliant solutions. Advanced pollution control technologies that industries can implement. This workshop will focus on advanced pollution control technologies that industries can implement, best practices from leading industries on sustainability, regulatory policies, government environmental compliances, collaborations between academia and industry to drive innovation. We are privileged to have experts with us today who will share their valuable insights and experiences, guiding us towards a more responsible, resource efficient, and environmentally resilient industrial future. On behalf of Department of Chemical Engineering, I extend my sincere gratitude to estimated speakers, industry professionals, faculty, and participants for joining us in this important initiative. Let us work together to create a future that is more sustainable, technologically progressive, and environmentally responsible. Thank you, and I wish you all thoughtful and fruitful sessions in this workshop. Thank you.
Thank you, Professor D. Appalachia, for a great welcome.
It is our privilege to welcome the guest of honor, Dr. P. Srinivasra Garu, environmental engineer from Andhra Pradesh Pollution Control Board, Zonal Office, Visakhapatnam. As the tradition symbolizing knowledge, wisdom, and enlightenment, we now invite our esteemed dignitaries to light the ceremonial lamp. This marks the beginning of our conference with the hope of illuminating new ideas and fostering meaningful discussions.
We request the dignitaries on the stage to move for the lighting of the lamp.
And I also request Professor Kumar Pachigolgar to kindly give his presence on the stage for the lighting of the lamp. Please give him a round warm of applause. I request the organizing committee of this workshop to please come onto the stage.
I request the co-chairman, Professor Pulipati Kingaru, and
Joint Secretary Dr. M. Tukaram Bayak Garu to please come onto the stage.
Professor Sujata ma'am, Professor
Professor Sujata ma'am, please come on to the dais.
Professor S.V. Naidu.
I request Professor S.V. Naidu to please be on the stage for the process. I request Professor S.V. Naidu to please be on the stage.
Keep quiet, right? It's your tradition, కదా మధ్యలో చెప్తే బాగోదు అంతే కదా మీ ట్రెడిషన్ కదా మాట్లాడకూడదు అంటారు అవుతా ఇలా టెన్షన్ అది వాళ్ళకి తెలిస్తే బస్ ఐ సే థ్యాంక్ యూ we thank all the dignitaries for their presence for the ceremonial వెంకట్రావు గారు తెచ్చారు అక్కడ శ్యామాసుని పిల్లదా ఇక్కడ సార్ ఆశ్రమం సార్ వెళ్ళిపోయారు శ్రీనివాసరావు గారు ముగ్గురు వచ్చారు ఎప్పటి వరకు అయిపోయింది ఈయనంట ఈయన
Thank you all the dignitaries for their presence on the stage, and I request everyone to take their respective positions.
Now it is our privilege to welcome the guest of honor, Dr. P. Srinivasrao Garu, environmental engineer from the Andhra Pradesh Pollution Control Board, Zonal Office, Visakhapatnam. We request him to grace the stage with his presence.
As we proceed further, it is time to present the convener's report encapsulating the vision, objectives, and key takeaways of this workshop. We now request Professor V. Sridevi Garu to deliver the convener's report.
A very good morning to one and all. I am highly honored and feel privileged to have been given the opportunity to address everyone on this very special occasion. As a convener of this program, I feel today is a very auspicious day. We all have gathered here to discuss about an important topic, sustainable practices for industrial pollution control, organized by the Department of Chemical Engineering, Andhra University. We are privileged to host someone who has helped countless lives through dedication to community service. He is none other than our chief guest, Dr. Prakasham Tata Garu, Honorary Professor in the Department of Environmental Sciences, Engineering and Management of Andhra University. A warm welcome to the guest of honor, Dr. P. Srinivasrao Garu, Environmental Engineer, who has accepted our invitation even though he is having a busy schedule. It's my pleasure to welcome President of the inaugural function, Professor P. Appalnaidu Garu, for accepting our invitation and for sharing their insights and expertise with the attendees. Today, we have the privilege of being in the presence of a true visionary and leaders in the field of environmental sustainability. Our experts have dedicated their career to finding innovative solutions for a greener and more sustainable future. A warm welcome to our experts, Dr. Prakashan Garu from US, Professor Kumar Garu from UK, Dr. Selvaraj Narayanasamy Garu from IIT Guwahati, and Dr. A. Gangagni Rao Garu, IICT Hyderabad, who have accepted our invitation to give their valuable lectures. We are deeply grateful for their presence here today and look forward to their valuable insights. It is with immense pleasure. It is with immense pleasure and honor to invite our co-chairman of today's function, Professor Pulipati Kingaru, for his kind support, suggestions, and guidance given to us to run this workshop smoothly. I feel honored to welcome co-convener Professor V. Meena, Organizing Secretary, Dr. M. Tukarambai, Joint Organizing Secretary, Dr. P. Venkatrao. It is a moment of extreme pleasure to welcome our sponsors, Professor G.J.V. Jagannath Raju Foundation, Divi's Laboratories Limited, Visakhapatnam, Ramanamurthy Garu from Sri Vriksha Junior College, and Ramal Garu from HPCL. We wanted to take a moment to express our heartfelt gratitude for unwavering support of our co-sponsors. Your kindness and support will always be remembered and cherished. I am truly grateful to have you as our sponsors. I am also delighted to invite our esteemed retired Professor P. Sujata Madam, Professor S.V. Naidu Garu, Professor Padma Sri Madam, and other dignitaries of the dais, Professor Balamohan Das Garu, former VC, Acharya Nagarjuna University, and my dear faculty members and faculty from other departments, delegates from the industries, a warm welcome to one and all. My dear students, participants, and volunteers, it's my pleasure to see such enthusiastic faces here today for this workshop. Your participation is truly appreciated, and we are excited to have you join us on this journey of learning and growth. A warm welcome to press and media. It gives an immense pleasure to brief opening report of the workshop. I'm very happy to inform that we have received a very good response. Around more than 500 members from various colleges, NITs, IITs, industries, and the members from the research institutions have registered for this program. We aim to provide a unique communication and discussion platform for environmental scientists as well as any discipline of science aiming the protection of the environment from industrial pollution by implementing sustainable practices. We have 4 lectures, 2 lectures in the morning session, offline mode, and another 2 lectures in the afternoon session through online mode. Regarding the present topic, there are so many research works are being carried out at various institutions, industries, and R&D centers. For example, the effective biodegradation and upcycling of plastic waste into value-added products, advanced e-waste recycling technologies, novel strategies in biohydrogen energy production, thermal processing of biomass, conversion into fuels, chemicals, and power. Controlling industrial emissions and waste management is another challenge that can be dealt with advanced learning missions and smart networks that could detect leaks, potential hazards, and diversions from industrial standards and government regulations. Some more research areas, for example, researchers at the Center for Energy Studies have been working at and alternate fuels, mainly hydrogen-produced vehicles for transportation. Hydrogen fuel has near zero emission and is capable of solving the twin problems of energy emission and energy degradation. A team of researchers from IIT Delhi Textile Department targeting at sustainable vehicles 3D textiles, replacing the steel structure of automobiles with a 3D fabric mode from glass, carbon, and natural fibers, which can reduce fuel consumption by nearly 25%. The researchers at Center for Rural Development and Technology, they have evolved a technology to convert agricultural residue into biomethane, thus generating energy, and silica-rich biomanure, evolving an eco-friendly platform for reducing the pollution. So we are thankful to the researchers and innovators who have contributed their valuable time to find ways to fight the persistent menace of pollution. I'm sure that you all feel enriched with knowledge after completion of this workshop. I would like to request everyone to kindly cooperate with us throughout the program, have a fruitful discussion with the experts, and make this event successful. Thanking you. Thanking you all.
Thank you, Professor V. Sridevi Garu, for providing us with a comprehensive and insightful report. It is a privilege to welcome the guest of honor, Dr. P. Srinivasrao Garu, Environmental Engineer from Andhra Pradesh Pollution Control Board, Zonal Office, Visakhapatnam. Having a distinguished personality in the field of environmental regulation with us today adds immense value to our discussions. As we progress further, it is now time to hear from our chief guest.
We are honored to have with us Dr. Prakash Garu, Executive Director of the Center for the Transformation of Waste Technology, USA.
With a vast expertise in waste management and sustainable environmental solutions, his contributions have been pivotal in advancing innovative and practical approaches to global challenges.
We now invite Dr. Prakash Garu to take the podium and lead the gathering.
Good morning. Good morning to students. How are you guys? Good morning. Get good morning. Come on, get up. All right. Distinguished guest on the stage. Beautiful women, particularly. But if you think that might be being the most senior in this group, ప్రకాశం రాజు గారు వీళ్ళందరూ ప్రాధాన్యత ప్రవేశం ఇచ్చేదంటే నాకు 43 ఏళ్ళు సార్ అలవాటు ఉన్నాడు ఎన్నికలు జాగ్రత్త పాటించి గట్టాలని కాదు This is the water conference, sustainable development process. So we recite అపోసిష్టామయోభవ తనూజ్య దదాతన సర్వస్వతోరసః సక్ష భాగ్యేశ్వర ఋషిదేవ మాధవరంగ అపోజనయత జనః ఓం శాంతి శాంతి శాంతి. What it means is we are addressing the holy water. Because of the presence, the atmosphere is so refreshing and empowers us with vigor and strength. Water is the primordial source for sustainable living for everybody. See, this presentation I got up at 3 o'clock in the morning because I was just wondering what to say at the inauguration. I thought my voice is good. That's okay. You know, oftentimes, can you hear me now properly? Can you hear me? Okay, good. Oftentimes, you know, environment regulators, environmental professionals these days, we talk a lot about environment. You know, when I started in this field as a young person like you, nobody talked about environment. Not many anyway. But today, lots of people, even in the common street, talk about environment, water, pollution, air, soil contamination, pesticides, and so forth. So I would like to talk about something about the genesis of the regulations, how it happened in the world. When the world is very primitive, in other words, you know, everything is pure and pristine, very few people in the world, and lot more resources are available. Air is plenty, water is plenty, although it's very finite. The soil is exuberant per capita in acreage. So all these things are dwindling. So first of all, I talk about a little bit about air pollution because lately I hear about air pollution in Vizag, air pollution monitoring stations, and my friends were telling me about that. So how this air pollution regulations have evolved. The first air pollution effect, I would say, an adverse one, was noticed in the Meuse River region of Belgium in 1930, after the Industrial Revolution, that is. Previously, we thought everything is pristine pure, but somehow they noticed that the river culture, because people lived around the rivers, sometimes immemorial. This was noticed first in the industry, because of the Industrial Revolution. People were living, a lot of water is needed for industry, that's where it started happening. In October 1948, because these are my notes, my classroom notes, you know, in the United States when I was a student, my air pollution teacher was telling me, an environmentalist who doesn't know his history is destined to doom. You have to know how these things happen. In October 1948, due to smog in Donora, Pennsylvania, 20 people died because they were breathing in a polluted air in that, because of smog, because of an inversion smoke signal. There is some evidence also in Vizag, in our valley, these things can be concentrated, pollutants, particularly in winter time. Believe it or not, the 20 people there died, which is 43% of the population living in that village. So that is a tremendous effect on the population. In October 1948, in Donora, Pennsylvania, 20 people died, and there is a repercussion of that. Then people started thinking about air pollution regulations. In the Bhopal tragedy, on December 1984, in December 84, it was caused by the methyl isocyanate, which is a pesticide gas, escaped from the Union Carbide plant. An estimated 150,000 to 15,000 to 20,000, 50,000, 20,000 people died. And about 500,000 people were affected. Even today, the soil around that area is highly contaminated, and the groundwater is also heavily polluted. So you can imagine the effect of one incident, the Union Carbide premises, although it's in any type of a company given by Union Carbide of the United States of America, a lot of people died. And about $470 million equivalent was paid as a compensation at that time. Now you can imagine If it is 1984 like that, now you can imagine the value, how much it is, rupees. Now the latest, in our hometown, in Visakhapatnam, on May 7, 2020, the siren incident. How many of you remember siren incident in Visakhapatnam? One, two, four. Raise your hand. If you don't know it, you better know it. If you belong to Visakhapatnam, you better know it. Your lives are in danger. When I heard this thing in America, I felt so sad. Can you keep a value for a life that is lost for a mother? Huh? If it is your child, just downgrade some money. What does it mean? Does the life have a value? Can you put a value on it? I don't think so. Even a beggar's child, we may think his life is trivial. But for her, for the child, the mother who is begging in the street, very precious. Just remember that. 1 crore for each of the family they gave. 1955, the Air Pollution Act was passed and funded by research for scope and source of the population in America. 1955. Not earlier than that. Although the incident was known in Belgium in 1930. In 1967, the Clean Air Act was authorized for the development of a national program of air pollution in the United States. They authorized research because they don't know much, they don't have much information. They have to get some information about the pollution, what's going on there. In 1967, the air quality actually authorized enforcement procedures. This is one thing is very important. You may have lots of regulations, but if they are not enforced, what is the purpose? 1970, we established a national ambient air quality standard. This is during the time when I was a graduate student. Just at the PhD years, everybody is talking about national ambient air quality standard. So one great thing about research in America and so forth, we don't have to rediscover the wheel. The human health is equally affected. They may look white and tall and so on and so forth, rich, but the body chemistry reacts the same way about the pollutants. So we don't have to rediscover by the research. Hazardous air pollutants and so forth. 1977, amendments for the Clean Air Act was they were again added, and again more research was done, the prevention of significant sources of pollution, all these things happened, and established a program to phase out ozone depleting substance. But you can look at the development. So what I'm trying to say to you students is we are synthesizing so many chemicals every day in the world. What kind of an impact it's going to have? They may be solids, liquids, or gases. We don't know. Do we know the effect of styrene? 75 years ago, we don't know. Similarly, the hazardous air pollutants, these toxicological studies were made. The standards were devised based on the toxicological studies. They are not just pulled from the air. A lot of research has been done. So we don't know in the future also what kind of chemicals are going to be synthesized, what kind of pathogens are going to be evolved. COVID-19, who the heck expected the COVID-19 before? With thousands, hundreds of thousands of people died. Then only people awoke. From 2000, when it happened, I was traveling actually from Singapore to here. As I said, there's this thing is going on. And everybody is having a mask. Even today, I see a lot of people are wearing masks. Just because the dust or whatever. So what I'm trying to say is, similarly in water pollution, for example, we revere rivers in India. The greatest example is Kumbh Mela. Half of the people in India, I think, went and took a dip in the what is it? That's Sangamam. Triveni Sangamam, right? I dare not go there because I just came from the United States, and I hugged some people who had taken the real holy dip, and they brought me some water. I'm a Hindu, and then they sprinkled water on me. Plant purified that way. So, half a billion, 500 million people went there. That is the fate we have in water. And why the hell we contaminate that every day? Does it make sense to you? We call it pristine pure and all that. I tell you one example. In Chicago, when I was a student, I learned 1887. 12% of the population of Chicago died by drinking polluted water. Their main water source is Lake Michigan. In 1889, the sanitary district of Chicago was evolved. They established it. And they were so aggressive in protecting lake water, the Lake Michigan water. The first thing they thought was the Chicago River is going into the Lake Michigan. It's best to reverse the flow of that because all the pollution is coming through that. Everybody is discharging into the river there, and that river is entering into Lake Michigan, and we are drinking that water. The water treatment plant which was in existence at that time could not filter it because there was a flush of water in 1887, and it could not kill all the bacteria and viruses and so forth. So they drank it. At that time, Chicago was like a village. 12% of people died. Immediately reacted. The engineering feat is the reversal of the Chicago River so that they won't want pollution to come into the Lake Michigan. They did a lot of dikes and breaks and all kinds of things they did it to reverse the flow. When I was reading that, about that incident, and when they say cholera and typhoid caused that, I said, my God, I want to be a physician. If I had only 5,000 rupees, I could have been. I didn't have any money. Then Paul American changed my life. Although his mindset is to cure the disease, he asked me one simple question. We're talking, he didn't ask me any questions or equations or things like that. He was talking generally about pollution. And he mentioned to me, what do you think prevents 80% of the people in India are suffering from waterborne diseases? Do you want to prevent them or cure them or what is it? And I know because after monsoon season, a lot of people used to go to the doctors. Why? Open defecation and all that. So I said, I have to think because my mindset, like you, to become a chemical engineer, at that time I want to be a physician, I don't have the money to go to medical school. So I started in biochemistry, or something. But this man, this tall man, the simple question changed my life. I said, I have to think. And I told him, sir, the ounce of prevention is better than a pound of cure, isn't it? And in Bengal, a Telugu fellow, why would he get a job? But you know what? One fine morning, I got a letter. I'm appointed as a research assistant. I jumped on the case and I talked to my professor. And then he said, Prakash, you go there, because you are professor. These were the kind of professors I had at that time. They changed my life. Do you think your professors are going to change your life? How many times you talk to your professors? Interact with them. They have the wisdom. They will change you. Right? Give a class to these professors. Come on, give a class. Like that I can tell you, solid waste management. Same thing, an example. The Surat. Bubonic plague came in there. And it killed people. And you know what? You will be proud to know that the municipal commissioner is a Telugu fellow. I think his name is Ayyadevara Ramachandra Rao. Municipal commissioner. He went there, he checked the bubonic plague. He controlled it. It disappeared. There are great people. These are the kinds of people that you have to emulate. Take an example, even chemical engineer, a reactor designer, or somebody who can really, you can be proud of. Just think about them. Learn your history. When was the Haber process was invented? Why they did that? Even fermentation engineering, how this guy Fleming, discovered penicillin, fermentation engineering, winemaking, anything. Just get those kinds of inspiration from those people. I got it. If bloody Prakash Tata can do it, why can't you do it? Huh? Look into it. Don't have to think about it. I'm sure, I thought, I'm not an engineer, by the way. I call myself a bachelor's engineer. I learned the process engineering when I was a student. Because in our field, a chemist or a microbiologist or a biochemist or a toxicologist or an analyst or something like that, they can be in the professions, but you want to really understand our field, environmental field. For sustainable development is a catchy word, circular economy. These are very fancy words these days. My grandmother used to practice circular economy. My great grandmother would be in the house. We used to consider the water channel to the drops. కాకరకాయ పోతుంది దేనికి చిక్కుడుకాయ పోతుంది బడి పెట్టింది మా ఇంట్లో ఒక ఆవు ఉండేది అది పేడ వేస్తే మా అమ్మమ్మ గాజీతో తీసుకెళ్లి ఆ యూరిన్తో కలిపి కాంపోస్ట్ చేసింది దాని కాంపోస్టింగ్ తెలియదు అండ్ those 9 months in our house we used to eat the vegetables grown on the composting material. Beautiful. My mother had a green thumb. Anything they touch. Even circular economy పెద్ద పేరు. Everybody talks about sustainable development is another thing. We sustain for 9 months. Now families are buying vegetables. Why can't you do that? Now you go to the vegetable market, you don't know how the health is. These things are treated. They have pesticides or something like that. So what I'm trying to say in this message, I'm going to stop in a minute. These regulations in our field are passed because of disaster, either public health or accidents. Then we think about formulating a regulation. Unfortunately, I travel around the world, and people go to foreigners, when they come to India, they want to see the Taj Mahal. You know what I want to see when I go to other countries? I want to see the sewage treatment plant, how they are operating it, and what they're doing, but it's something new I can tell them. So, what my suggestion to you is, learn these things, learn your history, be the best. Thank you.
The perspectives brought by Dr. Prakashan Papagaru have added immense value to this gathering. Thank you, sir.
Moving ahead, it is now time to hear from our guest of honor.
We are privileged to have with us Dr. P. Srinivasrao Garu, Environmental Engineer at Andhra Pradesh Pollution Control Board, Zonal Office, Visakhapatnam.
His expertise in environmental regulation and sustainable practices have been instrumental in shaping policies for future based on responsible environmental stewardship.
We now request our guest of honor, Dr. P. Srinivasrao Garu, to take the podium and address the delegates.
Respected dignitaries on the dais, off the dais, industrial representatives, and my dear students. I am very much privileged and honored to be invited as guest of honor to this international workshop on sustainable practices for industrial pollution control by my gurus, because I am one of the student of Andhra University. I pursued my MTech degree as well as doctorate degree from Chemical Engineering Department. It's really a great honor for me to be invited here. Before that, I am invited from AP Pollution Control Board. On behalf of AP Pollution Control Board, I would like to throw some insight what exactly AP Pollution Control Board stands for, what are their main functions, how we are implementing environmental acts and rules under various acts. Already our professor sir, Tata Prakashu sir, explained beautifully why environmental laws all over the world came into existence. He cited several examples of disasters, pollution disasters, where so many people have lost their lives. Coming to environment class, first time in 1972, one human conference was held in 1972, one international conference on human environment was held. According to this, we should have all over the globe equal common environment laws to to tackle the environmental matters. In this direction, our country parliament first enacted Water Act in 1974. Next. After enactment of Water Prevention and Control of Pollution Act in 1974 by the Parliament, Andhra Pradesh State Board was formed in 1976. Andhra Pradesh State Board for Prevention and Control of Water Pollution was formed in our state of Andhra Pradesh in 1926. Next. I would like to share already these environment provisions already incorporated in our national constitution through 42nd Amendment. What is this main provision of this? According to Article 51A, it is the duty of every individual citizen to protect and improve our environment, which includes forests, lakes, rivers, and all living creatures, and should have compassion towards living creatures. It is a duty, common duty of every citizen to protect our environment. That provision was incorporated in our national constitution through 42nd Amendment. Next. Again, in 1976, Andhra Pradesh State Board was formed. After enactment of Air Prevention and Control of Act, the name of board was changed to Andhra Pradesh Pollution Control Board. Next. We started with 2 regional offices, 1 head office, and we are working on 3-tier system. We are implementing our action plan through 3-tier system at regional level, zonal level, as well as head office level. Right now we have 13 regional offices, 4 zonal offices, 1 head office. What is the main? We are implementing all statutory provisions under Water and Air Act. Besides attending any public grievances or complaints regarding pollution matters, attending legal cases, as well as consent management of industries. What is the main motto of AP pollution control? What is the main objective, main mandate of AP pollution control? We have 4 main objectives. The first one is to bring out clean and healthy environment. The second one is identify what are the sources of pollution and suggest what are the remedial measures to be taken to control those pollution matters. And third one is encourage best practices like cleaner production measures. Right now we are saying that circular economy in industrial sector. And most important thing, the final one, create awareness among the citizens of India, among citizens, about what are the consequences of environment degradation, how to tackle this. In this regard, we are conducting several environmental awareness programs, workshops, and daily calendar, and educate them, enlighten them, sensitize them about environmental degradation. Various rules are framed and enacted. You just go through this: Water Act, Air Act, Hazardous Waste Alien Protection Act, which is called as Umbrella Act, under which so many environmental notifications are issued and being implemented in the state of Andhra Pradesh to maintain wholesomeness of water and air quality. Next. Next. What are the functions of AP Pollution Control Board? Enforcing acts and rules pertaining to environmental protection and attending public grievances regarding pollution matters. As and when we receive any complaint about any pollution, air pollution, water pollution, solid pollution, immediately we personally contact that complainant and address that issues in timely manner. We have given it a certain timeline period. Within stipulated time period, we have to address his grievance with the proper action plan. Next. Next. Okay. Today topic is simple. What are the various sustainable practices for industrial pollution control or others? I would like to tell you what is sustainable approach. Sustainable development and sustainable environment. Very simple. Basic thing is meet the present needs without compromising the needs of future generation by effectively using the existing natural resources. Don't go for over exploitation of natural resources. That is the sustainable. You can meet present needs, but just think in your mind that it should be available for future generation also. That is the basic concept of sustainable development. Here, I would like to tell you what are the sustainable practices. The first one is, before Jindal Urban Waste Management started the waste to energy power plant, especially in Vizag, wherever you observe, lot of heaps of solid waste present there. Am I right or wrong? Lot of solid waste. Right now, one of the best remedial solution for solid waste management is, right now this Jindal group is collecting around 1,200 tons of solid waste, municipal solid waste, which is being thrown by us and used in this waste to energy power plant and generating power. That is one of the best remedial measures as of now. Second one is GVMC, Greater Visakhapatnam Municipal Corporation, tied up with several industries to supply treated sewage water. Very fortunate that in Visakhapatnam we have around 4 to 5 major sewage treatment are there. Earlier, after treatment, they used to be disposed into sea. Instead of that, we enforcing the industry as well as also advising the local bodies, please tie up with surrounding industries and supply this treated sewage water. This is one kind of sustainable practice, one kind of water conservation technique. lot of fresh water consumption will be reduced by taking treated sewage water. This is one kind of sustainable practice. Next. And I'm very proud to say that Andhra Pradesh Pollution Control Board, whenever issue any consent, any permission to the industry, never allow any industry waste, especially liquid waste, into freshwater bodies like rivers, lakes, and ponds, compared to other states. Actually, CPCB stipulated certain standards. If they meet these standards, they can discharge into nearby inland waters, rivers, lakes, after attaining those standards. But when coming to state of Andhra Pradesh, we never allow any industrial liquid waste. Industrial, I am very specifically mentioning industrial liquid waste into nearby water bodies. Even though they are meeting, they have to use that water for their online application within their industry premises only. That is one of the best practices when compared to other states. No, okay. Here, we insisting all industries has to have functional ETPs or FTPs, effluent treatment plants or sewage treatment plants, to treat the trade effluent or process effluents or domestic effluents. After meeting the board discharge standards, then only they will be allowed for online application for plantation or irrigation, whatever it is. And also here, to monitor whether those ETPs or STPs are functioning, we insisted them to install online continuous effluent quality monitoring stations at the outlet of their ETP. And this system is connected to CPCB as well as APPCB portals for transparent and public access. Anyone can access into our website. They can view their standards, whether they are meeting or not. This is one of the best practices enforced by Andhra Pradesh Pollution Control Board. Whether they are meeting or not, how can we know? That is one of the best practices. Next. Also we insisting to develop. We always go for common effluent treatment plants in especially in industrial clusters like industrial parks, industrial estates, industrial areas, instead of individual ETPs set up by the number of industries in that industrial cluster. Otherwise, it is very difficult for not only pollution but for any state board to monitor all these industries. So that's why we are encouraging setting up common effluent treatment plants, especially in industrial clusters. And final one, implementing ZLE system by a few industries in state of Andhra Pradesh. According to ZLE system, whatever the liquid waste comes from that unit, they have to treat it, recycle it and reuse it. Even single drop of that liquid waste is not allowed to online application. Entire liquid waste must be recycled or reprocessed for any boiler makeup, cooling tower makeup, or into process, whatever it is. That is the ZLE system. That's the final one. Next. Coming to air pollution, we never allow in industry install without requisite air pollution control system to meet the board standards. Suppose all boilers generally use coal, biomass, or whatever. The some fuels they are using. They are generating emissions, contains carbon dioxide, SO2, sulfur dioxide, nitrogen oxide, several various environmental parameters. But before emanating into the atmosphere, they have to attain board standards. Here also, we insist continuous emission monitoring systems mandatory for at least more than 10 pph boilers. If anyone operates 10 pph boiler, they need to install continuous emission monitoring station in the chimney and connect to the APP CBC website for public access as well as transparency of whether we are meeting the standards or not. And we are encouraging industries to switch over from dirty fuels to cleaner fuels like CNG, LNG, biomass, and low sulfur fuels also. Recently, we insisted all industries to go for low sulfur fuels because several industries are using furnace oil. What we observe that it contains more than 4% of sulfur, which is creating water emissions in and around the surrounding environment, and we regulated them, stipulating a condition to switch out to low sulfur fuel. Right now, they are using sulfur content less than 1%. Then only water emissions will be controlled. Now they are switching over to low sulfur, like low sulfur heavy stuff, switching over to low sulfur fuels. And implementing certain siting guidelines for dust-prone units like stone crusher pulverizers, because stone crushers or pulverizers, especially they create lot of air pollution to the surrounding residential communities. That's why we put certain siting guidelines. How much distance should be maintained from human habitation? That these kind of guidelines are implemented by Pollution Control Board. Next. And coming to hazardous waste, right now, earlier they will generate organic waste, inorganic waste. Organic waste has some calorific value that can be easily disposed to cement industry as a co-fuel because its calorific value is more than 2,500 calories per kg. That's fine. But coming to inorganic waste, right now, with some modification, this organic waste, coming to inorganic waste, earlier the practice is to dispose this waste to landfill. It is closer threat to our environment. Instead of simple landfilling, instead of simple thermal destruction of organic waste, if we divert this organic waste and inorganic waste with some proper modification to bring out more than 2,500 calories, then if it is disposed to cement industry, that is the best option. Instead of landfilling, instead of simple thermal destruction through incinerator. And we also are proud to say that Andhra Pradesh Pollution Control Board is the first state introduced Andhra Pradesh Environment Management Corporation. Any kind of hazardous waste must dispose through online portal, through APMC portal by generating online manifesto. Means that waste is managed by kernel to grave. Means where it is generated and where it is disposed, entire end to end will be wanted through this APMCL digitalization. That is the advantage of APMCL. And coming to plastic units, fortunate to say and unfortunate thing, there are two things. Fortunate thing is we are monitoring plastic units to not to produce, not to manufacture any banned single-use plastic items. Fine. But unfortunate thing is, still we are observing a lot of single-use plastics as well as carry bags less than 120 micron size in our society because of illegal trading activities. They come from other states. Even though we are regulating the industries, but we don't have any power on trading activity. That will be lies with concerned local bodies and concerned municipalities or concerned gram panchayats has to take stringent action against traders who are using these single-use plastic items in our society. Next. Sir already told what is circular economy. Very simple. Earlier, our economy is linear economy. Take, make, use and dispose. Use and throw. That is the concept of our thing. If we go for circular economy, what happens? At least we can recover, we can recover as much as possible of all the value from all the products by through recycling, refurbishing, remanufacturing, reusing of products and raw materials. Maximum utilization of products and raw materials through circular economy, then it will prevent over exploitation of natural resources. That is the circular economy concept introduced recently for industries as well as commercial for anyone. Next. These are the 11 focus items where we need to go for circular economy. Simple, we have to recover as much as possible from that products or material till end of its life. Not simple throwing into that road. Electronic, scrap metal, all these things. Next. AP Pollution Control Board encouraging all industries which are going for waste recycling, co-processing of these waste in cement industries as a fuel, as well as already I told you the example, reuse of treated sewage. That is also one of the sustainable practice. And as well as promotion of common effluent treatment plants. This is the about circular economy is going to be bring a massive revolution to reduce the environment impact. Next. And our Honorable Prime Minister Ji, Narendra Modi Ji, has introduced one massive movement, that is Mission Life. Very simple. What is Mission Life? Everybody, including me, we always blame industry for pollution control, pollution matters. Why don't start ourselves? Mission Life nothing but life, nothing but changing lifestyle for sustainable environment in our daily activities. If we follow these principles, if we change our lifestyle, definitely there is a drastic improvement in the environment. That is the main mode of Mission Life. Simple. Those who are practicing lifestyle which is close to nature, they will be called as pro-planet people. What are those practices? I will cite few examples. Next. Next. These are the themes introduced by our Honorable Prime Minister Narendra Modi Ji. Energy conservation, water conservation, say no to single-use plastic, adoption of sustainable food systems, reduction of waste, adoption of healthy lifestyle, reduction of e-waste. These are the practices we always come across in our daily activities. The first one, energy conservation, simple. Encourage public transport, use LED bulbs, go into carpooling instead of individual transport. And water conservation, go for everyone should have rainwater harvesting system in your houses. Use drip irrigation system for most for efficiency of your water usage. These kind of next. Energy conservation. I would like to cite few examples. LED bulbs, public transport, switch off. All these are very silly, but if you practice in your daily activities, definitely there could be a drastic reduction of pollution which impact our environment. Next. Next. Water conservation. Already I told you, we always implement rainwater harvesting system like this. Next. Next. Say no to single-use plastic. Always use only cloth bag or jute bag. Never use plastic bags. Already these are banned. If it is more than 120 microns, still it is banned. So try to avoid usage of cloth, plastic bags. Next. Next. Sustainable food system, encourage millet system, everything. Next. Waste reduction. Just you recycle, reuse of old newspapers, cloths, magazines, whatever it is, the entire waste must be. If you segregate dry waste and wet waste, that is 50% success at domestic level. But we are not practicing. We just mixing it up and handing over to the municipality. Next, healthy lifestyle in our daily life activities. If we introduce millets or some healthy food, it will be better. Next, e-waste reduction. We always go for a new mobile. Okay, fine. But before going for new mobile, at least if you dispose your old mobile nearby e-waste recycle bin, it is set up by some electronic shops. If you throw it in that electronic dustbin, at least it should go on to the recycling facility. Use rechargeable lithium cells, prefer cloud storage or pen drive. Next. Fine. Finally, the final motto, it's not our motto, if anyone not implementing standards stipulated under Environment Protection Act 1981, they will be penalized. They will be levied with environment compensation like fines, and also they will be penalized also. This is the last practice we are following. Next. With this, I would like to conclude my session. I'm very fortunate, I'm very happy for giving this opportunity. I'm thankful to Department of Chemical Engineering, Andhra University for inviting me here. Thank you.
Thank you, sir, for shedding the light on the crucial aspects and valuable advices on pollution and sustainability. As a mark of respect and appreciation, we now move on to the felicitation of our esteemed dignitaries. We begin by felicitating our chief guest, Dr. Prakasam Tatagaru, for his invaluable contributions and presence here today. We would like to invite Professor V. Sridevi Garu and Professor V. Meena Garu to take up the moment to felicitate our chief guest. Thank you, ma'am, for your kindful gesture. Next, we extend this honor to our guest of honor, Dr. P. Srinivasa Garu, for his remarkable efforts in environmental sustainability and regulation. We request Professor V. Meena Garu and Professor V. Sridevi Garu to come forward and felicitate our guest of honor.
thank you Professor V. Sridevi Garu and Professor V. Meena Garu for a kindful gesture. Before we dive into the much anticipated guest lecture session, it is our privilege to invite a dynamic academician to set the tone with a word of thanks. Let us welcome Professor V. Meena Garu, co-convener of the workshop, to extend her word of thanks.
Good morning to all the esteemed dignitaries on the dais and off the dais, respected guests, faculty members, participants, and my dear students. It is a great honor to stand before you today as co-convener of the International Workshop on Sustainable Practices for Industrial Pollution Control. This workshop is a testament to all our collective commitments to addressing industrial pollution and fostering sustainable solutions for a greener future. At the outset, I extend my deepest gratitude to our Chief Patron, Professor G.P. Rajashekar Garu, Vice Chancellor, Andhra University, for his support and visionary leadership in making this workshop a reality. I also sincerely thank our patron, Professor G. Sheshibhushan Rao Garu, Principal, AU College of Engineering, for his constant encouragement in fostering academic excellence. A special appreciation to our Chief Guest, Dr. Prakasham Tata Garu, Executive Director, Center for Transformation of Waste Technology, USA, for accepting our invitation and gracing this occasion with his presence. His invaluable experiences in environmental sustainability and waste management will undoubtedly enrich our discussions. I also express my sincere gratitude to guest of honor Dr. P. Srinivas Rao Garu, Environmental Engineer, AP Pollution Control Board, for accepting our invitation and joining us today. I am grateful to Professor GMJ Raju Garu, Head of the Department, Chemical Engineering, granting us permission to organize this workshop. I am also grateful to the President of the function, Professor D. Appalnaidu Garu, Chemical Engineering Department, for his support to encourage this workshop to organize in a successful manner. Our sincere thanks to the distinguished expert speakers, Dr. Prakasham Tata Garu, Executive Director, Center for Transformation of Waste Technology, USA. Dr. Kumar P. Garu, Professor, Teesside University, UK. Dr. Selvaraj Narayana Swami Garu, Associate Professor, IIT Guwahati. Dr. A. Gangagni Rao Garu, Chief Scientist, IICT, Hyderabad, for accepting our invitation and sharing their valuable insights. A heartfelt thanks to Professor Pulipati King Garu, co-chairman of the event, for his leadership and valuable guidance in making this event more successful. A special note of gratitude to our convener, Professor V. Sridevi Garu, for her outstanding leadership to make this event very successful. I also extend my thanks to Organizing Secretary, Dr. M. Tukaram Bhai, and Joint Organizing Secretary, Dr. P. Venkatrao, for their timeless efforts in making this event a success. My sincere appreciation goes to our main sponsor, Divis Laboratories, for their generous support in promoting industrial sustainability. I also extend my gratitude to our co-sponsor, Professor GJVJ, the Jagannath Raju Foundation, for their valuable support. I also extend my gratitude to other sponsors, Sri B.V. Ramanamurthy Garu, Sri Junior College, and Sri L. Ramal Garu, DGM, HPCL, for their support. I extend my appreciation to the faculty members of Chemical Engineering and faculty members of other departments, non-teaching staff, participants, research scholars, and students for their enthusiasm and commitment to this workshop. My sincere thanks to Professor Jyotsna Garu, Dean Computer Center, Andhra University, and her staff for extending their valuable support. A very special thanks to our volunteers for their dedicated efforts in ensuring the smooth execution of this event. I also extend my gratitude to the press and media whose coverage of this event helps in amplifying our message. Thank you one and all, and I wish all a successful and insightful workshop. Thank you.
Thank you, Professor V. Nagaru, for your kind word of thanks. With an engaging session so far, it's now time for a short refreshment break before we continue with the next proceedings. We request all the students to please move quietly in an orderly manner row-wise, ensuring a smooth transition. Our volunteers will be guiding you, so we kindly ask everyone to respect their coordination and follow their directions. But do remember that we have an exciting session coming up right after the break, so please be back in your seats after 15 minutes. I request everyone to maintain the decorum. To the high tea, and please move row-wise, coordinating with your volunteers. I request everyone to please maintain the decorum and be silent and peaceful. Volunteers are being requested to please maintain the students in silence. Request everyone to please all the students please be into the auditorium. I request everyone to maintain the decorum. I request the volunteers to kindly shut the doors. enjoyed the reception given there. And now it's the time for the second section to be continued. With great anticipation and excitement, into the most awaited session. Lecturers, distinguished personalities, in the respective field. It is an honor to welcome Dr. Prakash Tatagaru, a stalwart in environmental engineering and water resource management, and Professor Kumar Kathiragaru, a trailblazer in sustainable materials and energy systems. Their pioneering work has not only become industry standards but also paved the way for innovative solutions to global challenges. Get ready to embark on an enlightening journey into a wealth of knowledge and transformative ideas. Ladies and gentlemen, today we have the privilege of welcoming a true visionary, a pioneer in environmental engineering, and a force of change in sustainable development. A man whose contributions span over 6 decades, transforming wastewater management, water quality, and sustainability on a global scale. His expertise shaped policies, driven groundbreaking research, and empowered countless communities. A recipient of numerous honors, an international consultant, an academician, and a humanitarian at heart. With over 60 years of expertise in environmental engineering, Dr. Prakasam Tatagaru has made groundbreaking contributions to wastewater treatment, water quality sustainability, sludge management, hazardous waste control, and climate change mitigation. He holds a PhD in environmental sciences from Rutgers University and has served in prestigious leadership roles. Currently, he is serving as an executive director of the Center for the Transformation of Waste Technology and assistant director at the Metropolitan Water Reclamation District of Greater Chicago, and also an honorary professor in the Department of Environmental Science, Engineering, and Management Studies of Andhra University. He is a board certified environmental scientist and a recipient of several prestigious awards like Edward Cleary Award. His expertise has been sought after by global organizations like UNDP, USAID, World Bank, and prestigious National Academy of Sciences. He has served on committees of Water Environment Federation and as a research council member. His exceptional work has earned him multiple Lifetime Achievement Awards, including the prestigious Ellis Island Medal of Honor. Beyond his academic and research accomplishments, Dr. Prakasam Tatagaru is an active Rotarian and a member of WashRag and SRAG, leading humanitarian efforts in water pollution remediation, wastewater treatment, and solid waste management to improve environmental and public health. With numerous authored books, over 100 research publications, and a lifetime of pioneering work, his impact extends far beyond academia and industry. Through his non-profit Bharati Tirtha, he has transformed lives by providing safe drinking water, sanitation facilities, and education in undeserved communities. His contributions to pollution remediation, sustainable waste management, and renewable energy solutions have left a lasting impact worldwide. So without a further delay, let us all welcome Dr. Prakasam Tatagaru. Let's all be prepared to learn from a true legend. Please join your hands in giving him a round warm of applause.
అందరూ కాఫీ అది తాగి ఎవేగ్గా ఉన్నారు కదా सब जागते रहो क्यों सो देना nobody sleeps okay so this is a presentation I made. Maybe sometimes I've used some examples. I can walk కదా నేను పెట్టుకుంటే ఓకే that's good. Okay. Can you hear me now? Okay. Professor Sridevi told me, It is 1 hour presentation. Now clock it. My stage is 11:26. And the format of that is, I'm a student of learning. One of the people that told me, if you want to live a healthy life, you should learn one thing at least in a day, new thing. So I come here as a student to learn what's happening in my neighborhood. That is Vijayanagaram, Visakhapatnam, and Srikakulam. I love these places. So I will speak for some time, and then I met my good friend, Bhaskar Rao garu, MB Bhaskar Rao garu. He'll be coming. And he is the retired chief engineer at Andhra Pradesh Pollution Control Board. I know him as well as Sriramurthy garu for a number of years because these are the administrators and the enforcers. So I want to learn from them how our environment is being cleaned up and what they do, what are their frustrations. Every one of us is a frustration. And if you want to do something, it takes time. For example, whether you know it or not, I completed my PhD 22 years ago. There is not a dull moment in my life. And I didn't look for any other jobs or anything, although they came to me. It's a time for me to give back to my motherland and also the country that adopted me. These are the two principles by which I live. I went to the United States in 1962 after working for 7 years on rural development, water and sanitation issues. I slept on the floor where there was no electricity, no drinking water, big snakes in West Bengal. Even today I speak fluent Bengali. যদি কেউ এখানে বাঙালি থাকে না বাংলাতে বলতে পারবো তোমরা আমার সাথে যোগ করে তারপরে না এটা হলে পরে না তোমার সাথে বাংলাতে কথা বলবো তখন আমি শিখেছি 19 বছর যখন কোচিং ছিলাম তখন শিখেছি বুঝেছো ক্লাস করো and I learned Hindi by traveling by third class sitting next to the latrine because at Vijayanagaram there were no reservations and I was only 19. I want to change the world. At least this American professor there told you he's my inspiration. I emulate him every time I speak about that. And in a Bengal, West Bengal, state of Singur, Apur Babu, that is a very small village, only 560 people. I didn't know Bengali, but he offered me a job, I don't know. This is what he did. I became a man in that place. I learned how to live with other people, which is very important in our field. Don't work in your shell. Either chemical engineering, civil engineering, any other engineering, electrical, mechanical, these are basic environmental engineering. You learn from others. That's what I do every day. For example, today I met this beautiful lady here, Tukaram. I remember her name because this is one thing I do. You have to remember names. This is the third time Dale Carnegie said, if you say the name twice, you will remember the name. This is the third time I mentioned to you. Sridevi, of course, I met her a long time ago. Very nice lady. And Paul King, Vilandru. I found a new friend from Vijayanagaram, a great guy. He is following me. So, with that, let me tell you the story. At the age of 19, I started in this field. Somebody asked me this morning, how old do you think I am? Anybody? I told you can call me grandfather, all these students. But anyway, let me get to the point, because they will kick me out after 45 minutes. Stewardship and strategy for industrial waste pollution control. Again, these are the thoughts I gathered. There's nothing, I think, this new to you. If you're an avid student of chemical engineering, environmental engineering, or civil engineering, you know these things. But it is only for me to grasp some of these ideas, some of the thoughts, and present to you what happens in the United States to some extent. One great thing is about the United States or European Union or other developed countries is they have developed all these sustainable standards and all those things. It's for us only to implement, learn from them, apply to the appropriate conditions to suit our environment. When you do that, you don't have to worry about it. It's such an intellect here. It's not rocket science. For God's sake, if Qatar thought I can do it. I'm doing a plastic waste recycling plan. How many of you know about that? It's a 1.3 crores. I raised the money. Bharati Tirtha Charitable Organization contributed $10,000. You know, that $10,000 became $120,000. Where do you get a return on investment like that? And that too, for the environmental causes. This is how I inspired. You know, if you're a chemical engineer, what would you do after you retire? Think about it. Maybe you can give back to your motherland. Or elsewhere, where will you go in the world? Give it back to them. Knowledge should not be hidden. That's my message to you. What is this? What is that thing I got in the bank? Okay, that's true. My outline of this is some introduction. Why treat industrial waste? Already you know these things. Broad characterization, again, a review, just to say. And the categorical standards for the discharge of industrial waste effluent into publicly owned. Put it in the butt. Okay, put it out. I'll get it back over. So very good. Thank you. POTW is publicly owned treatment works, like a sewage treatment plant. Treating municipal sewage. My good friend, Professor Balaprasad, tells me there are several sewage treatment plants in Vizag. I don't know what the status of those things are, but one plant I went there, it's not working properly. But the thing is, these categorical standards are developed for industrial waste. The pollutants have a certain limit that you cannot exceed. So there are standards that were developed based on some toxicological studies. They are not taken from the air. Except one standard I know, total dissolved solids for drinking water. It's pulled from the air. Because I met the guys who developed in America these standards. I asked, why 500? Why is not 499? You know, people like us, Indians, we ask some questions like this. Why is it 500? He said, there is no standard. Five of us sat there and we put the number and put it there. That's what it is. So some of the strategies for managing pollution of industrial waste. This morning got a very good lecture from the Pollution Control Board, Dr. Srinivas Rao. And there's some numbers I've quoted. That's what. Okay. So what are the strategies for managing pollution from industrial waste? Of course, most of the students who are environmental in that business, they know what is a pre-treatment and pollution control technologies. See, one good thing is the chemical engineers and environmental engineers, they can treat any waste, no problem. But the question is about economics and acceptance and that kind of thing. We'll talk about that. And operational practices, regulations, compliance, and enforcement. Stakeholder engagement. This is very important. If you're doing something for the good of the people, you tell them, this is for you, it's not for me. I am working for you. I'm a public servant. If I go to a member secretary of the Pollution Control Board, he sits there in his office and he doesn't see me, he's not a public servant. If he puts his IIS, I will leave him right away. Why the hell? I mean, I'm trying to care, and if I have to wait there for 2.5 hours, why should I talk to that guy? That's why my friends are at the regional level. Some of the major industries in Visakhapatnam may be in status of measures to control industrial pollution. I requested Sri N.B. Bhaskar Rao Garu, who recently retired from the Andhra Pradesh Pollution Control Board as chief engineer, and now he's settled in Vizag. He belongs to Srikakulam. So he's our man. So is Sri Ramanti Garu. So is our friend Balaprasad, and so many others, Abulu, Adibul Kanjar, Kalavala. So I'm in good company. Continuing, biodegradable waste, these are animal feeding operations. So numbers in the bracket. They are called significant industrial users. USEPA gave a designation for them. That is the number. If you go to the USEPA site and you click for the critical for the pollution categorical standards and you punch that thing, you'll get numbers for that. Dairy products processing, these are all, grain mills, meat products, sugar processing, canned and preserved seafood processing, then non-biodegradable waste. It could be metallic and that kind of stuff. Hazardous waste, another thing this morning, Professor Srinivasan touched upon this, hazardous waste is a big thing. And they are very dangerous. You have to be careful with them. And industrial emissions. This is one thing, I tell you, our Visakhapatnam suffered a lot. So was Bhopal with the MIS disaster. So these emissions are very dangerous. Not only that, all the volatile organic compound emissions that comes from sewage treatment plants or any other industry, they have certain limits that you can let into the atmosphere. There are major sources, minor sources, something like that. The major sources definition is all these HAPs are hazardous waste pollutants. The total to 25 tons, then they are hazardous. They have to follow some of their guidelines, their major sources. Each compound can be added to that. There are 188, I think I remember, on the list. If they add up to 25 tons per day, that is very bad. Less than that, they accept it. And then industrial emissions, I told you, like I mentioned about this is one thing, unfortunate thing, when I read the styrene, my goodness, in Visakhapatnam this happened. And I talked with Professor Balaprasad and V.S. Prasad, the people who are in the committee. They have written a 383 pages report. It is nothing but a negligence of the people. They are paid to do a job. When you receive a salary, aren't you ashamed of it if you don't do your job? You should earn it, not be given a charity. They should qualify people. There's no negligence. Understand the process. You have to have repeated training to ensure the safety of the people. They might have gotten 1 crore per person. Is there a value that you can put this morning? I told you. You can't put a value for the life. If I die, my mother cries the rest of her life. Mothers are angels to me. They're gods. Some examples here, metal processing industry, again, a categorical standard number, that group, SIU, significant industrial user, that is designation. Plastic molding, electroplating, just only a few examples. You can see the big list. There are 59 of them on the list. Any reactive waste, any corrosive waste, radioactive waste, toxic waste, these are hazardous. Methane, carbon dioxide, particulate matter, volatile organic compounds, styrene, nitrous oxide, sulfur dioxide. These are all the gaseous emissions, and the industry do discharge them. Acid rain is caused by sulfur dioxide and so forth, and nitrous oxide, you get fertilization of the water bodies and so forth. I told you these categorical standard treaties for 59 SIUs, 1974 to 2024 in guidelines. They update sometimes, Central Pollution Control Board. They also publish effluent standards and guidelines. There are 74 categories. That's the reference I gave you. Thank you for inviting me to this lecture because it gave me an opportunity to brush myself, to read something about India and the Central Pollution Control Board. I'm grateful for that. Metropolitan Water Reclamation District of Greater Chicago pre-treated standards. I am really, really blessed and fortunate because it's my dream in India to end up at this organization. Because they do practical stuff. I was on the faculty of Cornell University and Ivy League campus. But like any other professor, you have to scrounge for money. Little reactors. Everything is little, then you depend on the students. The good student will always leave you. Then you're looking for a good student. It's a little bother for me. And the job came to me in a conference like this. They asked me, would you like to join us? Very good. That's my dream, even in India, to go there because of the work they were doing. They are some categories. For example, even if you look at CPCB, this caught my eye. Thermal power plants, 25, thermal power plants, 33, I don't know what the differences are. I have to learn this thing. Thermal power plants with flue gas desulfurization, thermal power plants ditto, with water consumption, using seawater, using fresh water. USCB listed only one category under this category. So we are even more meticulous with the different categories. You don't have to find out whether the standard is applicable or not. And MWRDGC, the organization I worked there for 29 years and retired as the head of the R&D. So I had a lot of fun doing it, studies, on large scale studies, interacting with the operation maintenance people, law department, the engineering department, everywhere. I'm like the thing, I have 13 PhDs in my group. Secretaries of each section, 6 of them beautiful women, one my personal secretary. So I had a lot of fun with them also. So where can you lose this kind of a facility? And then you do things, if you want to isolate one battery or one aeration tank or something you want to study in a big scale, that is almost like a single unit for treatment for a city like Visakhapatnam maybe. Because water reclamation district, the area, metropolitan area has 5 million people. And then 5 million industrial population equivalent. So almost like 10 million people's wastewater comes to our plants, 7 plants. And then they have ordinances, which are fast, I think. April 9, 2015 is the latest edition for sewage and waste control industrial waste ordinance. There are a lot of pages. Instructions for reporting cease and desist orders issued for non-compliant industry. There are instructions. And somebody, we have, for example, this is my prayer sometimes. I pray for Andhra Pradesh pollution. I'm from Andhra Pradesh, right? These people don't have staff, I'm sorry to say. I don't know how Siddhamati Garu and Bhaskar Rao Garu managed. There are only 5 people in my set. We have 130 people in the industrial waste division. We have a helicopter that can go up and see anybody discharging into the waterways. We have Kalbalam at the army. We are all army people. Anything happens, Dr. Thana, we have a problem. Right, hustle, I'm coming, running. I'm not free now in the meeting. No, I jump and go. Here, officers, they don't have time to come. They'll send Srinivas Radha Mr. అక్కడ పెద్దవాళ్ళు వెళ్తారు అవును కదా ఏమండి ఇతను యువకాలు ఉంటాడు ఇక్కడ మనకి పెద్ద సీట్ కావాలి ఐ హ్యావ్ టు ప్రిటెండ్ అండ్ బిగ్ షాట్ Hey, you're a public servant, man. Come on, there is a big hazard going on. You're sitting here. Come on. Get up and keep moving. మా ఫ్రెండ్ భారతదేశం చేస్తాడు రమ్మంటే టక్కన లేస్తాడు నాకు ఇద్దరు పావులు పిలిస్తే మాట్లాడతాడు శివ శ్రీరామూర్తి గారు బయటకు వచ్చేది మొన్న నాకు సహాయం కావాలంటే ఇద్దరు భాస్కర్ వచ్చి ఎవడొస్తాయండి అలాగే ఉడికో నో ప్రాబ్లం ఈవెన్ బాస్ వుడ్ కమ్ ఎక్కడ కమ్యూనిటీ వాట్ ఎ లక్కీ ఫెలో ఈ ప్రొఫెసర్ ఎవరైనా వస్తారా మీకు పిలిస్తే చెప్పండి ప్రొఫెసర్ లాగే ఎవరు రావాలని అప్పలేదు కూర్చుని మాట నవ్వుతున్నాడు కింగ్ గారు నా ఫ్రెండ్ అందుకే నేను కటింగ్ జోక్స్ అయితే సీరియస్ అంతకన్నా నన్ను ఆవిడ పిచ్చిందండి రామన్ ఆవిడ పిలిస్తే ఈయనేమో చీఫ్ గెస్ట్ వరకు ఈయన చెప్పాట చెప్పింది నాకు సార్ నాన్ కంప్లైంట్ స్టాండర్డ్స్ కూడా దేర్ ఆర్ డిశ్చార్జ్ లెస్ దెన్ 200,000 అండ్ స్టాండర్డ్స్ గెట్ 500,000. This is the maximum concentration that you can let us into our treatment plant. If you go above that, we have a system. They analyze, we split samples with the so-called significant industrial units, SIUs, and then we find somebody is exceeding the standard, we tell them. And we compare the analysis with them. If there is a anomaly, we check it again, and then still we found exceedances, we call them. Hey, what's going on here? We don't want to punish them. We want to sit with them and talk with them what's going on here. See that this is started. We'll give the chance to explain and correct the situation. The reason why is you don't want to shut the industry because you lose jobs. So the loving hand, we tell them, that's what happens. These are the things that we do. And we see the maximum contaminant concentration allowed for discharge into receiving waters. We, in turn, all these effluents, we discharge into waterways, receiving waters, they used to call it. We cannot discharge anything more than this on the right-hand side. So while we are able to control something, the industries, we are controlled by the federal government. We're in a peculiar situation. We have to hold hands with everybody. We'll be punished too if we don't exceed their standards. I don't know what the rules here are. Unfortunately, I can tell you, even if your rules, there are not enough people. If I were the boss in the environment, everybody talks these days environment, I give them more than 100 people in industrial waste for Andhra Pradesh to do that. And I will not hire an Indian IAS officer who is from economics or some other bank and history major or this or that. They don't know. They're jack of all trades and they won't listen to these people here sitting. And they're afraid of these guys. And they in turn are afraid of the big shots, politicians. I had interactions with them. Their fear is, if they worship their thoughts, they will get transferred from Hyderabad or Visakhapatnam or something to Ichapuram or Barampur or something like that. There is nothing, their family living over here. So this kind of lafada doesn't happen there. I am an environmental engineer. I am the boss. If I don't perform, my boss will fire me. Simple as that. What are the strategies? You know all these things. Scrubbers for air pollution, filtration of particulate matter, catalytic converters and reverse thermal oxidation for volatile organic compounds, wastewater treatment, various physical, chemical, biological, and a combination of those things, depending on what thing, and ZLD, zero liquid discharge, ultimate, crystallization, all those things. Again, this is a good technology. Ultimately, you will have pure, clean water, and then some salt remaining below 10 GPM. These are some guidelines, and that is so from Stockholm. One of the fellows did some paper, and I got hold of that just a long time ago. Below 10 GPM, what is crystallized? Spray dryers 10 to 50, crystallizer only 50 to 100. Reverse osmosis, electrodialysis, reversal electrodialysis, crystallized combination 100 to 150 ppm, 50 to 100 ppm. So all three. So again, chemical engineers are well suited for this. Believe me, work with civil engineers for the construction of the plants, process design. You work with them. Don't sit in cells. This is a cell chemical engineering department. This is environment science, technology, engineering, management department. This is environment. I understand there are three groups here. One is chemical engineering, the other is environment science and technology management. There is environment science department also. Why can't we work together? Somebody said we have to work together. The previous slide also, the BA. Let's work together. Typical industry semiconductor, these are the ones that they use. Semiconductor, power printed circuit, plating and metal finishing, pharma, food and beverage. Many pre-treated process to accomplish ZLD. You just can't do only ZLD, but you have to pre-treat the waste to get to that level. They are pH adjustment, neutralization, dissolve, air flotation, diffuse air flotation, absorption, degasifier, mixed with filtration, oil water separators, oxidation, UV ozone, hypochlorite, all this kind of thing, in combination with the other concepts that I mentioned here. For many years, vapor compression evaporation has been in practice, but this is very expensive because if you use large volumes of waste, 95% of distillate comes 5% brine, dry by crystallization. For large volumes, is expensive. What are the operational practices as a strategy? Process optimization to minimize waste generation, energy efficiency improvement. This again, energy. I don't know what's going to happen with the world politics and Trump being the president. Again, you may have the best technology and everything, regulation, compliance and all that. If the regulations are relaxed or you don't have to comply, EPA staff, I think they have, I understand about 65% of the people are going to be let go. Climate change, all this COP 29, 30, you don't believe in. Our president, he doesn't believe in these things. Although 95% of the Nobel Prize winners think climate change is a reality. So again, these politics, when they intertwine the technologies, we have a problem. You may have the best minds to treat the sewage, but the industries will have a relaxed posture. I can discharge. Yeah, nobody's going to catch me. That's what's going to happen in USA. My prediction is that's what's going to happen. So we have to be careful about this. This is essential. You know, if you have the conscience, this is my place, I don't get a damn. about regulations. I will make my environment clean. You can do it. Training of new treatment plant operators. I visit, as I told you, when you go to Taj Mahal, the foreigners would come, they want to go to Taj Mahal. And some people came to Kumbh Mela, Mahakumbh Mela to be with, in the 500 million people. And I, as I said in the morning, if I go to a big city, I want to see the treatment plant. What kind of operation they have, how their compliance they have. What can I learn from them? The way to operate. Recycle, reuse, reform, and all those things are there. Materials and treated approach. So-called circular economy. Our friend Srinivas told us this morning. See, this one, I in 1974, I published a small paper. My mother and grandmother, for example, in my own house, this so-called circular economy, way back. You can do it in your own house, you can practice this. In the bigger community, particularly collection, treatment, aerobic diets to get the biogas, the residue can be used for fertilizer in crops, and then the residue comes into human consumption, fish, animal feed, and algae, animal feed. The aquaculture effluent can be recycled, go to irrigation in crops, and stormwater retention point, you can do this. And lo and behold, after I published this, I didn't know that the quoted this site in Philippines, they did something like this in a poultry operation. I felt so good about it. Somebody read the web, I thought. So don't forget to publish your work. There is somebody out there who reads it, definitely. Circular versus linear economy, you know this. Straightforward, produce waste and discharge. Then recycle, reuse, repair, refunction, recycle. After taking all the things as Srinivas told me this morning, told us, ultimately you extract as much as you can and get rid of the other stuff. Very little, a fraction of it. Regulation compliance, permitting and reporting requirements. This is needed. This again is a question of compliance means enforcement. You have to have adhering to category standards and environmental impact considerations, monitoring and enforcement practices. Stakeholder engagement, this is very important. When I do something, I talk to people, I sit with them. Before Modi ji talked about Swachh Bharat and open elimination, that was a dream in Bengal. Shuno baba, chara Bengali shuno. Opur ami giyechhilam, sekhane meira sondebela era sab 4 people na jeto bare mate jeto. Ami bhebechhilam keno jacche ora. এখানে আরো বেশি কেউ যায় না তখন আমি বাঙালি শিখেছিলাম তখন ওরা বললাম কেন যাচ্ছে ওরা হাসলো আমার সঙ্গে কাকে মাগো বলে তুমি পকেট খ্যাপা নাকি কেন জিজ্ঞাসা করছো they are actually that is a social time and they're going to mad to do this and 2 women died also by snake bites that time at the age of 19 I said I must do something to eliminate open defecation and I did that in 2003 in Vijayanagar in a small scheduled caste scheduled tribe village. I eliminated 80% of open defecation because it's very difficult to eliminate 100% because the men go to the town to do the job. They're not going to come back to the latrines I built for them. Excellent. I thought they would sleep over there. That will be something like maybe if you're interested for the students only, I will tell them what the hell I did in my life. This is very important, community outreach. Same thing I did here, but it's not working. Plastic waste recycling. 1.2 crores. I didn't ask 1 penny from Visakhapatnam people. Not 1 penny. Because I took it as a challenge. Prakash Tara, you have to take this challenge and do it for Visakhapatnam. I mingled with 5 different, some volunteers, they were picking plastic bottles. I worked with them. That's what I thought we were doing. I bought them a pickup truck and now gave the machinery. Unfortunately, it's not working. There are problems on both sides. This is what public interaction is all about. You have to make everybody happy. Otherwise, now, but last 3 days, believe me, at my age, I sat in Kavaluppada and set that machinery right. It's working again. After 2 years. People here didn't care. Not my friends in Hyderabad also. I have that kind of a passion. My money and others' money is involved. So it should work. Technology and science and engineering never lie. It is the people that they don't perform what they promise to do and deliver to the people. That's the problem. partnership with environmental organizations. There are so many organizations now. Leaving aside PPCB, there are other organizations, voluntary organizations. You can talk to them and they see what kind of things they are doing, how they are successful. Can you learn something from them? Right now, there is a guy who is the advisor for our Pavan Kalyan. He's teaching a workshop in Parvatipuram. How many of you know that? Why the hell Prakash would know that? I know it. Because I keep my ears and eyes open. I talked to the guy. He's a Tamil fellow. And he called me and told me, sir, I'm doing that. Will you come and talk in Telugu? I would love to, but I'm stuck with this plastic recycling plant. It's working right now. Extension programs by academic institutions. I don't know whether Andhra University has extension programs, but in the universities in the United States, there is a section for extension. Those professors, associate, assistant, and they go into the villages to give them the proper technology and guidance. They work with them. Extended producer responsibility, EPR. Again, the guy who is producing these plastic bottles like Coca-Cola or Pepsi, they're responsible to take them back. They'll buy that. You can talk with them. Economic considerations. This is very important. I mean, you as an engineer can give the most expensive technology, but if I can't afford, what are you going to do? You go to Africa, South America, India, these developing countries. I have the best technology. You know, guys want to make money. Multinationals will go there. This is good for you. Maybe they treat the minister or the prime minister of this country, they will treat them like royalty when they go there. And then they allocate some budgets for these things. They have examples in Africa, Latin America, and places like that. In India also. They give a technology to you, and maybe you will buy it because the ministry is very impressed. And then we'll build it. They will give you little change in terms of a grant or something. Now you build these crores of things. And then they leave. Doesn't work. I've seen these places in Africa, Latin America, and India too. I sat once with Prakash Javadekar in the Vajpayee government. I asked him a simple question. How many treatment plants there in India? He told me something like 80-50 or 860. And he said also, that's the CPCB report, obviously, he read it thoroughly. 80 of them were shut down. These were designed by environmental engineers, multinational companies or whatever. Why they were shut down? Because they were not performing well. 80% of them not in compliance. In the recent CPCB report, more than 1,200 plants, sewage treatment plants were built, 100 plants were shut down. 87% not complying with the standards. Why? They want to build with a lot of capital cost. Somebody told me because they get a 10 to 20% up to kickback from the minister all the way from the top to the lowest division clerk. And the others they build. And there's no adequate staff to even to run them. Treatment plant operates a rare commodity. They are not trained properly. They give contractual work. I saw in Visakhapatnam. I walked there. There were two people. He doesn't know the difference between dissolved oxygen and BOD. I saw his notebook. How many of you do that? It's my country. That's why I did it. So I was born here. I'm in this field for so long. I want to learn. Okay? I don't mean that kind of a thing is happening everywhere. It is happening in my backyard. That I cry for that. Okay? Incentives of green technologies adoption. Yes, you get incentives, but are you going to use properly? Life cycle costing of equipment, pollution prevention pays. If you reduce or prevent the pollution at the source, you get a lot of money. You don't get into troubles. Now, I request my friend Bhaskar Rao garu to please come to the stage. And I really am indeed grateful to him because he just recently retired. He was the chief engineer for the Andhra Pradesh Pollution Control Board, and both he, Sriramati, please stand up a little bit. And these two gentlemen, Balaprasad, will you also please stand up, please? And Sridevi, also you too. These are the four people I revere, and there is another man I will tell you. That man, stand up, sir. This man, Jemakat Tata, he's a writer, he's a retired railway official, very intelligent. He tells me, Prakash, that it won't happen. It doesn't. He's like that. So I invited him to come here. Thank you all for that. Sir, take over. USB, USB. I'll come back when he finishes. Go down. Thank you. I'll come back again.
Yeah, good afternoon, everybody. So I'm very happy to have been being introduced to the mostly student community here, where I also pursued my engineering degree here itself. So the legendary and environment expert, Dr. Prakasham Tata, who is a global man. So we have to learn so many things from him. And before learning things on environment, we have to learn something else. When you see Prakasham Tata, because you're all the students being students, we should learn one thing, one important concept. That is, I am disclosing his age. He is around 90 years, but he is younger than me and you. So, first of all, as students or as retired persons, we have to learn how to be healthy, because we know everybody, health is wealth. So once we maintain the health, we can do any wonders. మాకు శ్రీరామూర్తి గారు కూడా మా కొలీగ్, ఆయన ఒక సందర్భంలో అన్నారు, ఒకసారి ఏదో మనం సంథింగ్ లాస్ట్. సో ఆ టైంలో when we were worrying, అరే this we have lost, what to do? సో దెన్ ఆయన ఒకటే అన్నారు, మనుషులు ఉన్నాం కదా, మనుషులు ఉంటే ఏదైనా సంపాదించుకోవచ్చు, పర్వాలేదు, సో నథింగ్ ఈజ్ లాస్ట్ అన్నాడు. సో there are certain things as students you have to learn from different exposures, different people, different persons. So anyway, you might have covered so many concepts on environmental pollution all around globe. So USA, Europe, India. So he is acquainted with everything. He is thorough. So, but he made me to add up few things as far as local conditions are concerned. So just I will try to make out certain things. What is here? Yeah, this is the status of coming to Visakhapatnam now. So Visakhapatnam is situated in the northeast coast. We all know, being we are maybe staying in Visakhapatnam, everybody of you know, there are major two hill ranges, the so-called Samachalam hill range and Kailasgiri hill range, and of course one side sea. So it is just a spoon-shaped basin we can see in the Visakhapatnam city. That's called by the environmental experts as bowl area. So this is the bowl, it is like a bowl. So bowl area. What is the problem with bowl area? Once it is a spoon-shaped, the water may be, because all industries are located in the bowl. So major industries like HPCL, Coromandel, etc. So the poor dispersion is the problem here. Especially in winter, inverse conditions are quite common. So, the defense authorities also, they have made certain restrictions for stack height, stack chimney heights. So suppose in the NTPC, that's outside bowl area, so they have provided about more than 200 meters chimneys, but whereas within city area, that is not possible. So chimneys are about 30 meters, 40 meters or 50 meters only. Beyond that, you cannot go. So that causes what happens is the emissions will be released at a very less height and resulting in poor dispersion. And major industries are Hindustan Petroleum Corporation Limited, which is a refinery, petroleum refinery, and another one is Coromandel Fertilizer Limited. It is a fertilizer industry. And Andhra Petro is a petrochemical industry. And RCL, it is a coke calcination industry. And port, Visakhapatnam Port Authority, we call it, they will handle so many hard cargo and soft cargo. And ArcelorMittal, they produce iron pellets. And of course, there are some industries outside the bowl area. In the outside, Autonagar is one industrial area. And steel plant, it is a major establishment which is integrated steel plant from coke ovens or from the storage of raw materials to end product. Even they produce bar steel billets also. So to that extent, it is a very integrated steel plant. And Pharma City, that itself is accommodating about 100 bulk drug units plus NTPC. The influence of all these industries will also be there on the bowl area, apart from the industries already existing in the bowl. So, point and non-point sources, including transportation, are the various sources of air pollution, especially, apart from water pollution problems. But here in Visakhapatnam city, air pollution is the problem. And out of the air pollution problems, PM10, particulate matter, or rather dust pollution we can call generally. Dust pollution is the very bigger problem in our city. So, the city is identified as critically polluted area in 2009 by the Central Pollution Control Board as well as Minister of Environment. Subsequently, critically polluted area means they have developed a index that's called CEPI, Comprehensive Environmental Pollution Index they have developed. And if the score is based on the air pollution, water pollution, groundwater quality, etc., they have measured. If that index is more than 70, they had considered it as critically polluted area. If it is 60 to 70, it is severely polluted area. And below 60, it is safe. So in that context, Vizag was developed an index of 70.82. So because that's why this has been declared as critically polluted area. So they have imposed a moratorium also, not to go for expansions, not to go for new industries to be established in the bowl area. So such a moratorium was imposed. And later on, subsequent to the moratorium, most of the industries, including port and HPCL, Coromandel, all together they have invested 1,830 crores. That is a very big amount. Earlier, that was only 433 crores total investment was, but that was upgraded to 1,830 crores between 2009 to 2013. So again, Central Pollution Control Board, they have made a fresh survey on the present nature of the pollution levels, and they have recalculated the index, and based on that, they have withdrawn the moratorium. So once the moratorium is withdrawn, people started expansions. So this expansion again added more pollution. So, but Pollution Control Board, of course, as a soft skills monitoring, we can say, real-time monitoring they have introduced to all the industries, and load-based standards, because you cannot go on expanding to the maximum level within the small area. So they have introduced the load-based standards also. And further, Hindustan Petroleum Corporation Limited, they have made to implement a sulfur recovery plant. That sulfur recovery plant, by recovering the sulfur from the off gases, they are producing elemental sulfur that they are selling outside. Otherwise, all that would have been generated as sulfur dioxide in the atmosphere. So, and flue gas desulfuration, because P.S. Rao in his inaugural letters, he was saying the HPCL is, they are bringing about 4% sulfur. 4% is very high. But whereas there was a lot of demands in the past to introduce only low sulfur fuels, crude, especially low sulfur crudes only, to bring in HPCL. But the government has been allocating only high sulfur crude to the Visakhapatnam, though area is very sensitive. And they have provided a tar distillation unit also. So the efforts are good. Efforts are good, and all the industries, all major industries, even though they have expanded to a maximum extent, they have provided suitable pollution control by equipments. But the problem is, even though you provide equipment to the maximum requirement, there is a chance of some breakdown. That breakdown may happen at any time. Even half an hour breakdown can make a lot of problem in the city because of the meteorological conditions. So I will discuss some issues. So availability of technology. So when we joined the organization around 80s, the electrostatic, most of the air polluting industry used to run with only cyclones or multi-cyclones. Having a multi-cyclone was a great thing in those days. So most of the units used to operate with cyclones. So there was a lot of plume, visible plume from the chimneys. And in those days, that was a credit for the industry to show an industry with visible smoke, because smoke untena adi industry and cheppadaniki indication. But nowadays, if you show industry with smoke, that is a disadvantage for them. So for progress sake, you have to show without any smoke. Practically, photo at least at the time of when it was not emitting smoke, they have to take a photograph and project it. So technology was very poor, and I do remember the electrostatic precipitate used to be imported from USA, which were dismantled in their country. So Prakash and Tata Garu must have encouraged you remove them in our country and give it to India, they will bear it. But anyway, some of the people who are interested, they have brought the equipment, they have reassembled and put the provided the ESPs to the some of the major establishments in place of multi-cyclones or cyclones. Similarly, bag filters only cloth type bags were there. They were not at all adequate. Now we are using glass fiber and other type of very latest bag filter system. Technology is now totally available in India. So even BHGR also, they are manufacturing ESPs. Very good technology is there, and we are able to sustain. The only problem is consistency in implementation of measures. This is a very big problem. I appeal to everybody, all the academicians, all the regulators, all the student community. We learn so much about the theory part. So we provide, because Prakash and Dadaga was also telling, they have provided so many treatment plants, they are not functioning. That is the problem. We jump onto some other subject. We provide something, we forget it. So we simply forget it and jump onto some other program. But simultaneously, we have to work on it. If you need the progress, if you need the right thing, to do the right thing, definitely you have to simultaneously work on all the projects, what are you have been implementing on site. So consistency is a problem everywhere as per my practical experience in the organization. Why there is a need of regulatory authority? Regulatory authority, if you think in the right perspective, the need of the regulatory authority is only to stipulate standards. You have to stipulate, you have to conform to the so standards. To that extent only, the regulatory authorities' role is there. But here what happens? Every day, one has to go to inspection. So the moment one enters the gate, he switch on the button of ETP and make the readings. So this would cause a kind of mistrust between the regulatory authorities as well as industry. Industries feel the regulatory authorities are not at all cooperate with them, but at the same time, regulatory authorities feel the industries are doing something which are not trustworthy. So this type of atmosphere is not at all desirable. Even in the absence of regulatory authority also, it is expected any entity, maybe an industry or or an STP, whatever may be, they have to operate in proper shape. Then there will be no issue. For that, you have to provide proper persons, proper mechanism, proper systems. That is the need of the hour. Once that is established, that is the effect, that is the difference when compared to ours and other developed countries. In the developed countries, the so-called real-time monitoring system has been there since long time. But the moment if something goes wrong, some kind of malpractice, if they go for, they will be penalized very huge, and they cannot sustain also because they cannot even operate their unit on the subsequent days. That was the problem. But whereas in our country, nobody bothers you. Real-time monitoring, they will try to fabricate something. So this is not at all desirable. You are all some of you may be come up as environmental engineers or chemical engineers or civil engineers. So you have to keep it in mind as a regulator, as an authority, or as an industry. We have to definitely try to meet the standards. If we are unable to meet the standards, we should try to rectify. Otherwise, you have to stop the production. Then only we can gain the trust of the public. That is the most important thing. And there are so many mechanisms for self-regulations. We know 19,001, ISO 19,001, ISO 14,001, and nowadays we call it ESG, Environment Social Governance. It is a new concept. This is a self-regulation, and once they have the certificates, they will be recognized by the total community elsewhere, and their product also are very much valuable. But in most of the cases, somehow they get the certificate, somehow the audits are done. So this is the problem. And one more thing is scarcity of water. Especially in tropical countries like us, we face a lot of problem in summer. But there is lot of overflow of sewage even in hot summer also. The drains are full. The water may be the dumping ground, maybe a lake or a seaside, water may be, that will be full of water. So we have to think. There are so many plans. Nowadays, municipal corporation also, they have started a project. They supplied the treated sewage to some of the industries for some time. Later on, I came to know that was discarded. So this is what I'm calling consistency. So once you take more time, no issue. If time is required, we can delay it by further 6 months or for 1 year, no problem. But once we started implementing a project, that should be permanent. So like that, in all Andhra Pradesh or Telangana or total India, there is surplus sewage. So if you are able to treat it properly, that can be used at least for the green belt purpose. In fact, as far as my knowledge is concerned, one effort is made at Kailasgiri to use the treated water for the Kailasgiri plantations, but that was also later on withdrawn. So due to various reasons. So the water may be the administrative plans or our efforts should be to see simply we call it reduce, recycle, reuse. But what is the use unless we are in a position to implement? You need not blame. If we start blaming, industries blame, pollution control board, public blame, pollution control board, government blame some his officers. So this is an unending story. Everybody is responsible. So we have to do our part. Everybody is human being. Nobody came from heaven, but we have to do our part. So as far as industry is concerned, I can say, as per my experience, The recycling concepts, ZLD, zero liquid discharge concepts, are somewhat better. And as Mr. P.S. Rao told in the inaugural session, in Andhra Pradesh, we are not allowing, AP Pollution Control is not allowing any chemical industries to discharge the even treated water also on land. This is because of the mistrust or safety factor to have a better safety. Even if something contamination is there, that the groundwater gets contaminated, or it may lead to some water body. So in that context, that's not being allowed. Only the biodegradable water that only be allowed to be discharged on land, not to the rivers or streams. This has been in implementation since long time in Andhra Pradesh and Telangana. So that's why at least we can say our Krishna, Godavari, and even Nagavali, other rivers are comparatively safer than elsewhere. Even Ganga, Yamuna, if you see, you must be watching through the television. Lot of pollution we often see because of sewage and other industrial discharges. But whereas the efforts made by the government, something is better. And marine discharges, some of the industries have been allowed to them, even Vizag also, the Magadar got a surplus course that's called, that leads to the sea, and some of the industrial discharges also join the surplus course, especially once through cooling system they have, that part is supposed to go, and sometimes during rains or storms, that water also joins the sea. So people always have a doubt whether it is treated. So, and the industries are unable to create the trust to the public. This is need of the hour. So there should be proper understanding. Our trust. Trust is very much important to be created among the public. Similarly, public also should not go totally in a negative manner. Otherwise, we cannot invite the industry in our country. We need industrialization. We need all type of development. So we should we should think water maybe in a logical sense, and environmental issues also we should think assess in a proper way. Nowadays, if you see the press and media, even olden days only scientific reporters used to be there. They only were reporting. But nowadays anybody is reporting that Samudram, especially sea loan in ఎన్నోసార్లు చూస్తుంటాను. 1 kilometer, 2 kilometers, it recedes back sometimes. Everybody is silent. And sometimes during rainy season, the sea is almost touching the wall of the beach. Then again, immediately they write, the global warming is happening, taking place, and Vizag is being submerged by sea. So maybe in the 10 years or 50 years, there will be no Vizag. So this is nothing but threatening or causing a kind of fear among the minds of the public. So unless we assess the things properly in a scientific way, we should not trespass into the scientific matters. That is very important. At the same time, I do agree, awareness of the public is very much important as far as environment is concerned. Unless you people, we people have proper awareness and questions the regulatory bodies and government, this much progress in respect of environment or the so-called levels what we see in Andhra Pradesh or Vizag city would not have been possible. And research on environment by industrial houses. Most of the industries, their production process or the quality of the product matches the present trend, whatever may be elsewhere, maybe USA or European standards. But as far as environment is concerned, they will lag far behind because they have lot of research. They work very lot on the research part as far as quality of the product is concerned, but they ignore the environment part. This should not be there. They should also think this is also a part of the their production. Then only it is possible. Most of the times they come to the pollution control. What I have to do? He is a producer. He is producing something, maybe a drug industry or a chemical industry, and he questions the regulatory authority what I should treat my effluents, what to do. It is his responsibility, because unless we go deep into the, no expert can have knowledge of total process more than him, who is the production in charge. So often people even research is also very much essential, and industrial accidents. The industrial accidents just normally reported in almost every month or so, somewhere of a year, especially in Pharma City and Achutapuram areas. The reason is the automation, lack of automation. Once if you carry out everything manually, what happens? The manual errors will be there. Somebody at home, he must have a quarrel with his family or some kind of problem, and he comes for the night shift and he start operating the some vessel. So definitely his mind will be somewhere how to counter next day. So definitely there will some happens a mistake in the process that end up as some major accident. So many accident or mishaps are happening because of the negligence, human negligence. So best thing is to improve the automation. If the industry representative also here, my appeal is to improve the automation in developed countries. If I am right, Prakasanda Dagaru, very big establishments, even one establishment itself will be located in 100 acres to 200 acres. So everything is automated. Of course, in our country also, the Jamnagar HPCL is a recent refinery, so they have automated. But HPCL, which is an old refinery, but still they have automated to the maximum extent. People will not go operate manually, but still, in spite of that, some accidents took place. So this is the problem. So we should think for the upgradation or automation. And here, PM10 is the issue of concern for everybody in the Vizag city. The reason is source emissions, that is point source emissions. No doubt, and confidently I can say pollution control devices are there and they're working to the maximum extent. The another problem is non-point source emissions. Non-point means storages. The storages are only just like heaps, they store it, and the mechanization, of course, in the port, some of the people have made some mechanization efforts, but still, partly it has to go on. And in industries also, it is not totally mechanized handling. So because of manual handling, that problem is happening. So, but still, I can say, in spite of all issues, Vizag is not only a peaceful city, it is still a livable city, but with a threat. So we have to, unless we work together, we cannot live in the city very happily, and the whatever may be the image of the city, we have to protect all together. Thank you.
Thank you, Bhaskar Rao garu. Thank you so much. I learned a lot from you. Give them a big applause. Now we close this with the last one slide. I learned a lot from Bhaskar Rao here. I agree with him at the last point. I go to Hyderabad, my sister lives there. It's so difficult for me to commute. The pollution is horrible. And it rains, it plugs up, you cannot go anywhere, potholes and all that. But when I come to Vizag, I felt so serene. That's for sure. Thank you very much for that. Now, as you know, we hear a lot in the newspapers as Bhaskar was telling, something is made up, something is real. It's up to us to find out. And the media write about and complain about the government, corruption, and how bad is our environment. But I don't see any article that we are living in a good environment in Visakhapatnam or something like that, as you said. We have to be critical in the sense when something is happening bad, but at the same time, equally, we should applaud the efforts of non-profit organizations or pollution control board or anybody who's involved in protecting the environment. We have regulations at the federal and state levels. We have pollution control boards, but then why most of our water bodies are still remain polluted? Of course, Bhaskar said our rivers are cleaner than other rivers, but I'm talking in general terms, other bodies in India. And my concern is, even though we build treatment plants, I told you earlier, we do not have adequate staff. Somebody sitting there in Delhi, they give some data to the United Nations or ADB or some other organizations. We think it is sacred. I have a doubt about that. We don't have too much of monitoring data to verify. We do not have, I think, in my mind, the appropriate standard methods and calibration of instruments and then verifying that processes on a regular basis. I suggest to universities like this, we have a central control board, laboratory with accreditation type of system. When new registrar has come, maybe you can talk, maybe you already have a laboratory, but if you give it a national laboratory accreditation type of a system, other industries can depend on you to get that analysis. Don't burden them with the analysis, but you can charge them. They can pay you some money, make some money for the students and the thing we did in America. It works. But we have to be like NELAP, we have National Environment Laboratory Accreditation Program. It has to be said, we have to be truthful. And our data can be checked by anybody in the world. That's it. You are the last word. That when you do that and inform the people, the industry, they will believe you. If you have good record and you tell them you're not doing well, they will ask you because pollution prevention pays. They can make a lot of money by preventing pollution. Personally, this is my observation. I think there is an immense shortage of professionals. It's like, see, I look at America, everybody is taking data science, computer science, basic engineering, nobody is studying that much. In my book, civil, chemical, mechanical, electrical. They are both those people who are looking for H1B visas. Trump is going to take care of them, I think. But these people have some mental problems also. Personally, I think mothers who send their children, I pray for them because they're in a dilemma as to what's going to happen under the Trump administration. He's not an environmentalist. I'm sorry. And also about immigration. Okay. So it is something that we should think about, particularly the parents, who are sending their kids and all. I tell them, let them learn basic engineering disciplines. Those guys can master anything, in my opinion, because I'm not an engineer, but I work with them. They were my students. I think this engineering brain is somewhat differently wired. They can learn anything, but not vice versa. Okay? If you are sincere about it, if you are depending on some short-term gains or something like that, please leave it and go to data. But here, get them, use them, kick them, pick their brains, and work. Work as interns, go to the industries and learn something, the industrial processes, chemical engineering principles. Then you can walk the talk. Don't look for a job behind a desk pushing files. These poor people, they are good workers, but I feel sorry for them because they don't have people who walk the talk. They can direct them. You cannot do that all the time. They are bosses. The professors are bosses. They cannot do all the time. The students have to do that. I did it, and why can't you? I'm doing it now. So please, this is our country. I see some African students do the same thing because I love Africans. I went to those countries. And we have the same problems. They have the same problems as we do in development. Corruption. Let's stop doing that ourselves at a personal level. I don't care about that. So this is my message to you. Walk the talk. What people like us, students, faculty, retired people with vast knowledge about think about them. They can keep them up. They can't walk like this, they become like this. But go and touch their feet and then learn from them, their guidance and so forth. Finally, my parting words. You have to have the passion for what you want to do in life. You have to have the passion. I repeat. I'm going to make you repeat this at the end of it. What is passion you have to have? Chemical engineering, statistics, mathematics, anything. If that is your passion, you have to have the passion. And sometimes things don't work. Then you have to have persistence. You have to work like a leech. Until the leech sucks all the blood and becomes round, it won't get off. You have to have the persistence. Second word, I'll make you repeat this at the end of this. Persistence. And then, the final. You're intelligent. Andhra University doesn't take the people from the street. Perfection. Yes, that's perfection. So what are the 3 words that you should emulate? I did. My professors, when they told me, my teachers, my gurus, and my fellow workers, whatever, the first word, say after me, passion. I didn't hear you. Second, persistence. Say it again. Third one, perfection. God bless you all. Be the best. Thank you.
Go to Portuguese. Yes, Prakash.
We extend our profound appreciation and highest regards to Dr. Prakasham Tatagaru and M.V. Bhaskar Rao Garu for gracing us with their exceptional knowledge and invaluable insights. M.V. Bhaskar Rao Garu served as the Chief Environmental Engineer at the Andhra Pradesh Pollution Control Board. In June 2024, he participated in a World Environment Day event alongside Andhra Pradesh Pollution Control Board member, secretary, and other officials, emphasizing the importance of preserving nature for human survival. Your lectures not only deepened our knowledge, but also inspired us to explore new possibilities. The wisdom you have imparted today will resonate deeply with us, guiding future generations towards impactful action. Moving forward, it is our privilege to introduce to a distinguished alumnus of our department and a dedicated philanthropist, Professor G.J.V. Jagannatharaju Garu, with a long-standing association with Department of Chemical Engineering, Andhra University. He has made remarkable contributions to academia, research, and institutional leadership. A scholar with 2 esteemed doctorates and an illustrious career spanning over 5 decades, Professor Jagannatharaju Garu has held key academic and administrative roles, including Professor, Head of Department, and Faculty Chairman at Andhra University, Vice Chancellor of Nagarjuna University, visiting faculty at IIT Madras, Emeritus UGC Fellow. Professor G.J.V. Jagannatharaju Garu holds several firsts to his credit. First foreigner to receive the professional technical degree from a technical university of Budapest, first chairman of the National Board of Accreditation, AICTE, New Delhi, first chairman of Andhra Pradesh State Council of Higher Education, first rector of Andhra University. Additionally, he served as chancellor of Sri Chandrasekharendra Saraswati Viswa Mahavidyalaya University, Kanchipuram, and contributed significantly to national education committees like MHRD and UGC and allied educational institutions. Jagannatharaju Garu's foundation was established on November 22nd, 1994 by Professor C. Bhaskar Sharma Garu, Professor R.V. Subbaraju Garu, and Dr. P. Venkateswarlu Garu. The foundation was created in honor of Professor G.J.V. Jagannatharaju Garu's vision. The foundation actively supports scholarships to assist deserving students in their educational paths, endowment lectures to promote academic excellence and innovation, community initiatives focused on education and social welfare, The Professor G.J.V. Jagannath Raju Foundation empowers future generations as it continues to uphold his visions and inspire progress. As we honor his contribution, let us strive to carry forward his intent and forward towards a more brighter and more inclusive future. Thank you. And now we keep the momentum going on with another powerhouse of knowledge and innovation. Our next speaker is someone whose work is shaping the future of sustainable industries and clean energy solutions. Get ready for an eye-opening session as he takes us through the next wave of breakthroughs in green energy, carbon capture and storage, and the future of sustainability. So, we kindly request your presence on the stage. Please give a huge round of applause for Professor Kumar Pachikolagaru. Professor Kumar Pachikolagaru's research is at the forefront of the global net zero movement, tackling some of the biggest challenges industries face today. His work focuses on efficiency, improvement, carbon capture, and storage hydrogen energy, and sustainable power generation, all essential for achieving a low carbon future. A trailblazer in net zero technologies, Professor Kumar Pachikolagaru brings a wealth of expertise in carbon capture, hydrogen energy, renewable storage, and is currently a professor in industrial decarbonization at TCD University, an alumnus of Andhra University in UG, and he pursued his PhD in chemical engineering from Hayward University and a career spanning top institutions like Stanford University and the Net Zero Industry Innovation Center. His research is driving real-world transformations in energy and industry. One of his key areas of expertise is alternative heat provision using microwaves and plasma technologies, revolutionizing industrial process to reduce carbon emissions. His work on high-temperature heat pumps and geothermal heating solutions is paving the way for industries to transition away from fossil fuels. Beyond this, he has played a major role in developing cutting-edge energy storage systems from molten salt for high temperature applications to cryogenic phase change materials for ultra low temperature storage. And it doesn't stop there. Professor Kumar Pachikolagaru is the leading research in sustainable mining, CO2 transportation via pipelines and shipping, and next generation renewables like concentrated solar power for hydrogen production. His efforts bring the gap between fundamental research and large-scale industrial implementation, ensuring that sustainability isn't just a vision, it's a reality. We now request Professor Kumar Pachikolagaru to deliver Professor G.J.V. Jagannath Raju Foundation Endowment Lecture on Waste to Sustainable Products at the Net Zero Industry Innovation Center. So the podium is yours.
Thank you very much for nice intro, and good to see my own picture in a video format. It's a pleasure to do that one. And at the same time, it's good that Jagannath Reddy Foundation is formed in 1994. I must say that I don't know that one. That is the year I started my first degree over here at Andhra University. It's a pleasure at 1994. That means I'm 1994-98 batch. So there are few of you. We used to sit at the back and listen to the talks given by the professors and eminent speakers. Like Prakasham Tatagar mentioned, what is that he mentioned? Your teachers, your professors will motivate you, your life will change. I'm the victim of that one. My life has been changed. I was proud to say that one. It is because of them only I'm here in front of you all and giving my eminent speaker and in terms of Jagannath Rajgar Foundation lecture. Particularly what practices and sustainability activities I'm doing over the past I can say that 5 years or so. I can't give everything in 1 hour, so I just give a few advancement and a few examples. To start with, this workshop is sustainable practices. That reminds me,
During my childhood, my mom used to do that lot of sustainable practices. You all do that as well at your home. Probably your moms might be doing it, like a plastics. If you see that, it's continuously using that plastics, wash it and reuse it, wash it and reuse it. At that time, it's a previous generation, they use it to do that. That is a sustainable practice of utilizing it, that plastics. Along with that, the newspapers. What do you do at the end of the month or 2 months? Your mom used to collect those newspapers. What will happen end of that one? It's selling it to the second hand one. So the value of that paper is more value compared to the content in it. Am I correct? Nowadays, we are not looking into that paper pretty much. It's a value, that's a recycle point of view, reuse point of view. Anyhow, to start with, I'm from northeast of UK, which is not same as, means far away from the northeast of the Vizag we are talking about. Somehow northeast is in bottom of my heart. In the UK map, particularly, I just want to show where we are and what we are doing. The dots is indicating the emissions of carbon. Particularly at this moment, I will talk about pollution control point of view, carbon and sulfur emissions, how we are controlling it. That dot signifies that amount of carbon coming out. Particularly at northeast one, Teesside and Humber region together is more or less 50% of the total UK emissions, majorly the carbon. Why is that? That is a pretty much around 60 plus industries are there closer to within the 5 mile circle radius. I can't say that that is pretty much the same as a Vizag scenario. Vizag has a similar number of industries, probably tens of them. In this particularly, we have BOC, hydrogen generation plant. That means you're producing the carbon dioxide. 50% of the UK hydrogen is supplied from that particular industry. So therefore, it is a substantially large emissions is coming from that sector. Along with that, what else we are doing at the Teesside, particularly as a region, like a Visakhapatnam, industry's point of view. This is one of the top class just now awarded last year over the Christmas time period by the current government. Investment of approximately 5 billion investment to decarbonize. We want to set the scene. We want to be a first of its kind, both nationally and internationally. This 5 billion pounds investment is mainly to do that carbon capture. So natural gas power plants, we are building it. In the UK, we don't have any coal-based power plant. We shut all of them because coal-based power plant tend to be lower efficiency compared to natural gas one. In this particular plant, at near Redcar and Middlesbrough, that is where we are located, 700 megawatts natural gas power plant. On the back end of that chimney, that flue gas going out, we are diverting it into carbon capture, capturing the carbon from that flue gas, the rest of them is sending it back into the atmosphere. It is pretty much like an absorption columns. You all study during your degree program. Separate that carbon dioxide absorption, desorption, pressure swing approaches. That captured carbon dioxide, what we will do that substantial amount of carbon dioxide is coming out. We are building the pipeline, approximately 140 kilometers pipeline infrastructure, both onshore and offshore, to transport it to the seabed where we recover that oil, that space is empty, storing that one under the seabed closer to like 2 kilometers down, deep down, and leave it over there with the time that will do the precipitation reactions and turn them into the rock and all other materials, minerals will evolve. Similarly, that Humber region is not far away, which is pretty much 20 miles away. There as well, we are trying to build the infrastructure to decarbonize the industrial sectors over there. That is what one biggest project, the groundwork is happening. And along with that, sustainable aviation fuel. So to decarbonize the aviation sector in a way that is to control the pollution and all those things in a different way, we are tackling that problem. This sustainable aviation fuel is a demonstration project. This is linked to 2030 targets we set. 2030 is not far away from now. It is just one 4-year undergraduate program you are doing. By the time we need to meet that targets. To meet that target, these are the first 5 demonstrative projects we are doing it. Altogether is approximately 200 kilotons per annum of sustainable aviation fuel we are producing using a different feedstocks, municipality, solid waste, biomass, or cooking oil, waste cooking oil, and all those things. Turn them into sustainable aviation fuel using the gasification and on the downstream, turning them into SAF through FT process. That is another demonstration happening in the Teesside region. And then reuse, recycle, reutilize it because of the minerals we are trying to use for our energy needs, particularly onto that EV side. Lithium is one of the precious mineral. What we are trying to do that is recycling the end of life car batteries, implementing a demonstration plant which we are trying to handle 150,000 EV vehicles equivalent to 50,000 tons of lithium waste a year. So recycling, upgrade them into the battery grade and feed it back so that it will be reutilized. But performance point of view, we need to see that how that is going to behave compared to that in its original form. So we got a lot of industry and a lot of demonstration projects are happening, high TRL level up to 9 or so. To give all the academic innovations into industrial practices, particularly the T side has a strategic vision, has invested around 16 million to develop the Net Zero Industry Innovation Center. Pretty young institute, 18 months into that program. I'm the first academic recruited to drive the force, means in a way that is academic research into the industrial practice. And we are located within those 60 plus industries as I mentioned there. Day to day, we work with industry. Industry is our neighbors, not located in the academic division. To do that decarbonization and the net zero, we considered the 5 thematic areas, particularly carbon capture and storage. Without that, if we are still dependent on the fossil fuel, without carbon capture, you can't meet the 2030, 2050 targets. So hence we consider the carbon capture is one of the thematic area within our new institute. And hydrogen is another aspect as an alternative fuel. If you replace with natural gas, what is that? Hydrogen is going to give as an alternative fuel. Like the same thing in the household, your gas cylinders, natural gas, methane, propane cylinders can be replaced with the hydrogen. So that is what we are talking about in the UK. Currently, our existing infrastructure can cope up 20% hydrogen coming to our houses. So that existing appliances can cope up with that one. That means our boiler system can cope up, our cookers can cope up with 20% of hydrogen. How the hydrogen is produced, you all might know, heard about it. Different color spectrums are there, rainbow color spectrum. Red, not red, particularly blue, green, turquoise, pink, you name it, some color is there, including the white hydrogen. It is pretty much like a naturally available hydrogen. So these are 2 technologies, one with smart systems and the digital labs is heavily supporting to improve the efficiency and reduce the resources usage point of view. Last but not the least, circular economy. That is a buzzword commonly using nowadays as a sustainability point of view. Those are the 5 pillars we have considered. To support that 5 pillars, non-technical activities like the social acceptance, policy, regulation, those are very, very important in the developed countries like the UK. And business proposition to move forward these technologies into industrial practices. So for this one, it is a pretty much initial funded by the European Union with local council, that is a Tees Valley Combined Authority, TVCA, and Teesside University. So what industries we are worked with? You name it, we have worked on. So that's I just gave a few examples, the local industries we are currently working on and developing the solutions, turning their businesses into green and at the same time making them into net zero. And we are creating as an example, particularly our building is totally like a net zero building. 80% of the materials used for our building construction is locally sourced and 80% recycled material. And we don't have any natural gas coming to our building. So powered through solar panels, a heat pump, and conventional, non-conventional solar thermal absorption chiller to provide the cooling load required for the building operations. Okay. Next one. Okay. So pretty much sustainable development goals is within our DNA and within our activities, you covering all the 17 goals with our research activities in Net Zero Industry Innovation Center. So as I mentioned, some sustainable practices, I just want to give you an examples of the activities we are doing. To start with the hydrogen. As I mentioned, initial investment to build the infrastructure and the state-of-the-art labs and initial recruitments like me. And we started with that. We secured, it looks like some delay, yeah. This is Research England Development Fund. That is normally proven to be like a Russell Group universities will secure it. Russell Group universities is pretty much equivalent to IITs in India. So we are proud to say that we secured that investment at Teesside University with support from Durham University, 11 million investment to build the manpower, resources, and the capabilities to expand our activity. The main focus being hydrogen. How hydrogen is playing a role in decarbonizing the industrial sector locally. As I mentioned, we want to be first of its kind nationally, some aspects internationally as well. Four critical thematic areas we have considered in the hydrogen: hydrogen for heat, hydrogen for power, hydrogen for transportation, and along with that, transition planning, the regulatory, public acceptance is pretty important. Without public acceptance, we can't even move a stone from here to there. That is very, very important in the UK and US and other places. To support these categories, we recruited 14 fellows, postdoctoral fellows, to provide the support and the mechanism to the local industry to understand their operations, how we will turn their businesses into green using a hydrogen as a fluid, as an alternative fuel. To give you some examples, this is one of the projects, couple of projects I will give you. Hydrogen to liquefy them to decarbonize the aviation sector, because aviation one is liquid kerosene is using. To replace that one, it is ideal case is hydrogen in the liquid form. Do you know that what temperature hydrogen will be liquefied? It is pretty much like minus 253, which is 20 Kelvin. Very, very low temperature. Ambient temperature, the Indian case is like a 40 degrees. So delta T is substantially, you will end up with a lot of losses. If you keep your hydrogen in a can like that one, it will go out. So you need to make sure that your system is well developed and well insulated so that these losses will be minimized. That is what we are doing it. Thermodynamic feasibility and economic viability of this liquid hydrogen putting into the aviation industry. So trying to create that exercise with support from the VOC Linde, that is a gas supply company, and Washington Cryogenics as a storage company, a small testing bed. We are in the modeling stage. Once that is proven, we will build a small scale liquid hydrogen plant and planning to realize and demonstrate into the Teesside Airport. Teesside Airport is one of the smallest airport in the UK. Other project within that REHIP is like a hydrogen, as I mentioned, that color spectrum. Along with that color spectrum, hydrogen, some other byproducts is producing. Even this morning, someone is mentioned clusters. That is what we are talking about. Someone's waste is a useful product, useful input requirement for the other neighboring industry. What we are trying to do that is a mapping through this blue, green, turquoise hydrogen production path. What are the other byproducts will be produced? What are the quantities? How that can be supplied to the neighboring industry? That is what we are trying to do that in this particular project. And the third one of the example is how hydrogen is transported, materials point of view. Chemical engineers is like evergreen, they know everything. That is what I'm applying. I'm doing even a material scientist job as well. I'm doing the chemist job as well. How these fluids are behaving, phase changes and all those things. And particularly on to this hydrogen for transportation point of view, what material you need to know, look into the hydrogen embrittlement and cracking, sorts of material you need to use, the types of coatings you need to apply, and the storage requirement if we want to store the hydrogen, how hydrogen is playing a role in your automotive sector, what sort of tank you need to consider to meet the safety regulations. All those aspects is considering within that project. And the bottom is the companies supporting and their vision to create their pathway. Along with that cluster hydrogen, we are doing some case studies as well. That is one of the example in the food sector. We considered 3 case studies. A local bakery and KP Snacks, like a crisps company over there. Corn Food is like a fake chicken company where they will cool that product and sell it to the local suppliers. Those key studies, pretty much they are using the fossil fuel for their energy needs. So we are providing the solutions through either high temperature heat pumps, utilizing the waste heat from the neighboring industry, lifting up their temperatures and developing that energy requirement. Along with that, if necessary, storing them in a phase change material. When it is needed, you can utilize it. Absorption chillers, that is solar thermal cooling rather than conventional vapor compression systems. And now into the greenhouse gas removal. That is pretty much onto the pollution control. What we are trying to do that, particularly in the UK, net zero strategies is pretty much linked to 80 million tons of carbon dioxide is coming out, and we need to remove that one. How you are removing it? Storing it under the seabed. One of the example I showed you through the CCS hub with the 5 billion investment. Along with that, we are trying to do that with direct air capture. So it is like we are trying to create as a national hub for national direct air capture unit. And then natural based solution as well we are developing, giving it back into the soil so that the carbon will be stored there. To that element, I just want to show you, as I mentioned, it is a young institution, over 18 months, how we moved our technology from the fundamental research into the industrial practice. Reduce this air pollution locally because of the capturing the air, so improving the human health locally over there because of even industrial pollution. We use like world's best technology like a fluidization to capture the carbon dioxide from the air using the calcium carbonate, calcium hydroxide as a material. We start with the bench scale as a picture over there to meet that requirement, and then we move it to pilot demonstration. That is, if you look into that annual basis, that is a 10 ton per annum capacity unit We tested in one of our labs, which is a unique pilot fluidized bed system. And now we are upgrading them into 50 tons per annum capacity unit, which is happened over the 18 months. As we speak, the unit is currently building at our place. That is our building, the new building, which is opened in September 2023. You can see that on the rooftop, solar panels. Behind is direct air capture unit and absorption chiller to provide the building heating and cooling requirement. And now, on that point, we are building direct air capture. That is a CAD impression of the physical unit, how that is going to look like. Pretty much the foundation is made, and the facility is building around the corner, around the shed. Once that is done, we have to be implemented there. When I go back to UK, that unit will be ready because of the deadline, the milestone. We put it by end of March. Okay, so that is where our building underway, what industry wants, scaling up, decarbonizing, and putting them into high TRL levels. So in a way, as a good example, academic research into industrial practices. And then I'll move on to the recycling and circular economy approach point of view. What sort of recycling and circular economy activities we are doing? Okay, so the SAF one, because there is one of the activities, demonstration activities is happening over there. At the T side, we are doing as well, using the gasification pyrolysis and the microwave examples, turning the different waste materials, including the plastics and the cooking oil and biomass, with the partial oxidation, turn them into syngas, and after that, a traditional FT process and some advancements is happening to make it down into the scaled down version with the novel catalyst in the multi-pass approaches, and then into hydroprocessing to turn them into eject fuel or so. That is one example. And another example is the waste coming from these materials, that means solid materials like a biochar or a fly ash and things. We are turning them into valuable products, either like into the catalyst or nanotubes, or applying them into the natural based one onto the soils to improve the growth of the plant. We done several studies in the Nigeria, applied that ash onto the soil to increase the growth by approximately 200% or so. We're done with pepper chilies and cassava growth. And then link it to the maritime, given that I'm from the here locally, so Vizag shipping one. So similar activities we are doing that as a green shipping corridor. What is that green shipping corridor? Replacing the marine fuel with the high sulfur content one. We talk about 3.5%. That is a similarly IMO, International Maritime Regulation, is implemented. This is a pretty much a novel process we are considering, and the patent is currently under review. So what we are trying to do that is to meet that 5% scalable zero emissions by 2030 with different shipping sectors, either electrical or hydrogen-based systems. Based on that fuel, the nautical distances in the current practice is going to give. However, our green methanol as a approach is scalable even further because we are recirculating the carbon dioxide. So carbon dioxide is not emitting from our process. So then you can ask the question, how that is happening? The approach we are considering is continuously getting the hydrogen either from the wind energy or the solar energy through water splitting electrolysis, or directly if it is a GCC countries or in India, to eliminate the unit operation, unit operation, that means a desalination, directly do that water splitting to produce the hydrogen. However, that has some implication. because of the salts, electrodes, and the catalyst will be corroded. That is some research need to be done how to make the low cost material with less corrosion for chlorine and oxygen. That research as well happening within our T side at this moment. So that produced hydrogen, turning them into methanol. To turn them into methanol, you need a carbon dioxide. I will come back where and how that carbon dioxide is coming. We produce that methanol, and then what happens? We transport it to the port and put it onto the ship. It could be ro-ro ship, it could be passenger or a chemical container. There within the ship, we are reforming. That reforming means splitting them into hydrogen and carbon dioxide. That hydrogen is used and the carbon dioxide is going back into the loop. So that means we don't need a carbon dioxide into the system until unless there are losses, a top up is required. So that methanol can be utilized as an alternative fuel, particularly as we talk about heavy fuel oil or a high sulfur fuel. Nowadays, talking about low sulfur fuel as well. For that one, you need to meet equivalent to the pollution control board we are talking about, UK, EU, ETS, environmental trading scheme, and along with the fuel EU emissions point of view. Those are the penalties need to be implementing over there. That is where and how we are controlling within decarbonizing the marine sector. To do that exercise, we are doing the project as a pre-commercial trials, demonstrating how this solution is going to look like. Reformer is, as I mentioned, we put the hydrogen reformer into one of the Aberdeen buses as a part of the previous project. We are utilizing that reformer to do that exercise in one of the ports in Northern Ireland. 150 kilowatt capacity unit we are building, demonstrating, engaging all the stakeholders relevant to realize that particular solution. We used ro-ro ship, DFDS1, between Northern Ireland and Great Britain, which is onto the northwest of the UK. That is where the current route we have considered, UK, northwest, and then Liverpool, and the Larne is Northern Ireland. The distance we have considered is approximately 150 nautical miles, which is pretty much double to northeast to Netherlands. As a case study, we have considered because the data we received from the operator, the FDS. And this is a route and how the scheme is going to look like. I don't want to spend much more time, but I have mentioned it. This infrastructure required to implement within the port premises. Like means port authority engagement, health and safety aspects, and everything is we are considering and including within our project. That is about greenhouse gas emissions reductions and advancements point of view. However, this morning we talk about ZLD. So there as well, we are doing a lot of research I'm doing on advancing the minerals mining point of view, linked to desalination program. Means after desalination, some of the waste concentrated brine solution is the dumping back into the sea as a practice. However, that has an impact onto the marine life. It is creating a unsustainable solution. So therefore, we are talking about zero liquid discharge for that environment. Well, that means more water you can produce and minerals can be recovered. How we are doing it? That is another patent solution we are creating. This is just to give you the sorts of brine is coming out from the desalination plant, what value it can create in a way that if you make your sums correct, techno-economic aspect, it will give a revenue generation of 1.6 billion per year if you consider handling all the concentrated brine solutions coming from across the globe from the desalination plants. So what we are doing in relation to that one, brine mining, That is a crystallizer, multi-sequential crystallizer operating at different conditions and different minerals we are recovering it. I don't want to go much details over there because the patent is currently under drafting. However, we are doing the carbon capture as well there, preparing like the sodium, magnesium carbonates, sodium chloride, potassium sulfates. In the end, we are producing the lithium carbonate as well because the lithium is important for the EV batteries point of view. As the growth is going up, however, lithium availability is very less and we are heavily dependent on the China or something geopolitical scenarios point of view. You need to make your own way of identifying the supply systems. So particularly we are concentrating on producing the lithium carbonate to creating an additional resource. However, in these concentrated brine solutions, very tiny percentage of lithium is there. Economics may not be favoring, but always my motto is, if you do first of its kind, economics is always expensive. When you do that mass production, economics will come down. However, we tested with concentrated brine solution, geothermal waters in our test facility, which is we considered as a 50-liter capacity. We tested and proven that one, brought it to the technology readiness level to 4. And this is another interesting project, egg recycle. After eggshells at the bottom left-hand side, you can see that we separate the membranes, crush them, process that one. I don't want to go through in much details about the process, producing calcium carbonate because that eggshells do consist of substantial amount of calcium carbonate. Feed that calcium carbonate to the paint industries or pharmaceutical industry. Last but not the least, this is a complex flow sheet diagram, which you all know that utilizing on this one. I just want to highlight biomass to biofuel in an integrated approach. We are considering with zero waste, zero pollution scenario with approximately 4 industrial companies we have considered. Aparag biorefinery plant in Orissa, Kashyap in Hyderabad, Telangana, and Bajaj in Uttar Pradesh, and the 4th one, I forgot, it's not top on my head. It is a European program. I was coordinating. If it is awarded, pretty much 60 crores of Indian rupees in total, supported through Department of Biotechnology in a vision, utilizing all the waste, turning into the sustainable practices. That's with that one, I'll stop. Thank you. Okay.
A heartfelt appreciation to Professor Kumar Pachigolla Garu for an eye-capturing lecture presentation on waste to sustainable products, insights on carbon capture systems, direct carbon capture, REHAP Project 7, and industry innovation. And we also appreciate his enlightening discussion on high sulfur fuel oil and its environmental impact, and also low sulfur fuel oil and scrubbers. Furthermore, his insights on lithium extraction from brines using multi-crystallization with carbon capture highlighted innovative approaches to sustainable resource recovery. We are honored to felicitate Professor Kumar Pachigolla Garu for his remarkable and exceptional section. Now, we would like to invite Professor V. Sridevi Garu, Professor V. Meena Garu, and to come forward, take up the moment to felicitate Professor Kumar Pachigolla Garu. We now request Professor Kumar Pachitala Garu to kindly remain on the stage. We invite Dr. Prakasam Tatagaru to join us on the stage to felicitate the President of the inaugural function, Professor D. Appalnaidu Garu, and the esteemed members of the organizing committee of this workshop. We request Professor D. Appalnaidu Garu onto the stage for the honor. Now, we kindly request Dr. Prakasham Tatagaru and Professor Kumar Pachitala Garu to come forward and felicitate our convener, Professor V. Sridevi Garu, and co-convener, Professor V. Meena Garu. We now request Professor Pulipati King Garu onto the stage to felicitate N. Bhaskar Rao Garu. N. Bhaskar Rao Garu, we request your kind presence on the stage for the felicitation. We request Sri Ram Murthy Garu to come onto the stage. We request the dignitaries to felicitate C. Ramanamurthy Garu. We now request our organizing committee chief guest to felicitate Sri Ram Murthy Garu. We now request our chief guest, the organizing committee and the dignitaries to felicitate our convener, Professor Sridevi Ma'am Garu. We now request the dignitaries, our chief guest and organizing committee to felicitate co-convener Professor V. Meena Garu. We now request the dignitaries and the remaining organizing committee to felicitate. We now request the remaining dignitaries, our chief guest and the remaining organizing committee to felicitate our co-chairman, Professor Pulipati King Garu. We now request our joint organizing secretary, Dr. N. Tukaram Garu, onto the stage, and Dr. P. Venkatrao Garu onto the stage for the felicitation movement. We request Chandana Garu to join onto the stage. We also request Professor G.V.S. Sharma Garu onto the stage for the felicitation. Professor G.V.S. Sharma Garu, we request your presence on the stage. Now, we request the dignitaries to present the mementos to Dr. P. Venkatrao Garu and Dr. N. Tukaram Garu. We now request our dignitaries to present the memento to our Joint Organizing Secretary, Dr. M. Tukaram Garu. Let us give them a big round of applause. Thank you, dignitaries, for your kindful gesture. With that, we conclude the morning section of our workshop. A big thank you to all our speakers and participants for such an insightful session. Now it's time to the break on recharge. We invite you all to proceed for lunch. Enjoy your meal. Food coupons are already kept inside your file. We request all the delegates to kindly check your files. We kindly request all the volunteers to guide the participants towards their respective counters, and all the participants please kindly coordinate with your volunteers. I request everyone to move in an orderly manner. The delegates are requested to move row-wise. Volunteers, please kindly check with that. I kindly request everyone to please coordinate with our volunteers. They'll guide you to the outside door. Please move in an orderly way.
Yeah. So